Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, today in this particular video, I am going to discuss about a very important topic which is called as deep agents. If you see most of the companies like ChatGPT, if I talk about Cloud Code, if I talk about Maunus AI, they have their own deep research agent, and this entire deep research agent are nothing but they are called as deep agents. Now, how it is different from a normal agent, normal AI agent that we used to create. If you see the flow of the development, specifically in the field of generative AI, agentic AI, initially we used only LLM models to create generative AI applications. Then we moved towards creating independent agents which were able to perform some tasks. Then we saw different types of agents. Then we also probably saw, how to probably collaborate between agents like multi AI agents and all. And those kind of applications we have focused, and all these kind of videos have already been uploaded in my YouTube channel. But now it's time that we move towards deep agents. So in this video, what we are going to do is that we're going to understand how deep agents are. I will also show you some code, how you can actually create your own deep agents. But in the upcoming videos, we'll talk more about it with respect to practical implementation. So now quickly, let me share my screen. So here it is. So initially, if I talk about other agents that we used to use, right? Now, what are agents? First of all, it's a very simple thing. Let's say that I have an LLM. Okay. This LLM, let's consider that I give an input to this LLM. Now, this input to the LLM, right? The LLM basically acts like a brain. So this will basically act like a brain. So the LLM will take a decision whether it needs to generate the output or whether it needs to communicate with some kind of tools, right? Now, these tools can be any tools. It can be an external third-party tools. Let's say that if the LLM is not able to generate the output, let's say if I ask a query, hey, what is the current temperature of Bangalore or Paris, right? So LLM obviously do not have any kind of live data, right? So the LLM is usually connected with tools. Now, these tools can be, a SERP API, it can be a Tably API, it can be different kind of API which gives some kind of weather information. Now, after the LLM is making a request to the tool, then the tool basically gives the output saying that, hey, the temperature for Paris is so, and that specific output is basically generated. Now, this is also an agent. This is a basic agent, right? I can call this as an agent. And this specific agent, we say it is called as a shallow agent. Now we'll try to understand what exactly is shallow agent. Why we are saying it as shallow agent? Because the input query that we are giving, the LLM is taking an action, it is calling the tool and it is giving the output. So here, a specific flow, they are just following, right? And finally generating the output. Here, we are not again communicating back to the LLM, or here you can see in this particular process, no planning is happening. Just a request is coming, and based on this particular request, the request is basically going to the tools, and that tools are actually giving us the output, right? So here you can see that there is a very simple loop, right? It is a very simple loop, and this is the most common functionalities we may have implemented in our generative AI solutions or AI agent solutions, right? Now here, there is also one more disadvantage. See, based on the input query, there is only one logic getting applied where a LLM is taking the action, whether it needs to call the tool or directly it should generate the output. So here, no explicit planning is there, right? Like a query has come, LLM is taking the decision and finally generating the output, right? And this kind of use case, like whenever we use this particular use case, we don't use it for a very complex task. Let's say that if I give an input query, hey, try to probably find or try to provide me the recent AI news that is happening today and how it is probably related to economics, how it is probably related to, what are the best development that are basically happening in the field of physics. If I ask this kind of complex query, then that query needs to be decomposed, right? It needs to be decomposed into sub complex queries, right? And then it should be probably solved. And based on this particular flow, the complex queries cannot be handled, right? Complex queries cannot be handled. It cannot. You can basically see that it cannot be handled. It is very simple. You may be thinking it is simple, but it is not. Okay. And even whenever we are following this simple loop, right, there is a very limited context retention. Limited context retention. right? In order for the agents to work properly, right? Usually what happens is that you need to have good amount of context. Now in this particular scenario, just one flow output is generated, the context is not there, right? So these are the simple problems that you can see in this particular agent. So that is the reason we say this as shallow agents, right? Because of it is just having a simple loop. You can see that no explicit planning, complex queries cannot be handled, because for complex queries, you need to divide that queries into subqueries. We need to assign sub agents to solve that particular queries and all, right? Now, you may be thinking, Krish, okay, fine. If this is a kind of agent that you have created, we have also heard about different agents. One of the most common agent that we know is something called as React, right? React agent. Now, inside this React agent, what happens is that, let's say that you have a LLM. So, this is the LLM. This LLM is actually connected to many tools. Okay. LLM is basically connected to many tools. So here you can have Wikipedia tool, here you can have search API tool, Tably tool, different kind of tools can be connected over here, right? And this LLM is basically connected to the tool. And whenever an input query comes, okay, so this is the LLM. The LLM will be assigned with some kind of system prompt. Now, based on an input query, the LLM will make a decision which tool to call, right? After the output is generated by the tool, then the context will be sent back to the LLM. Okay. So what happens in this kind of agent is that the term react, okay, react. See over here, act is also there, and right? You can act any number of time based on the observation, based on the context that you're getting from the tools, right? So in this particular scenario, this kind of conversation, this kind of loop can happen any number of times. And once a complex query is solved, then you will be able to see the final output. So let's say that if I go ahead and ask a query, what is 2 plus 2? And then multiply by 5. And then multiply by 5. So in this particular scenario, first of all, this query will be answered, and then this query will be answered. Then both the context will be assumed to generate the final output. Now in this particular scenario, we say it as a React agent. So here, this is also an independent agent. And here, loop is also happening, right? And loop will be happening based on the output that is generated from the tool. See, output, once it is generated, the context is given, then the LLM will make a decision whether again we need to use any other tools or not. So there can be n number of tools over here, right? Now in this scenario also, right, we also say this as shallow agent. See, this is a best improvement of the above agent. Based on the above agent, yes, this agent is better. But we still cannot say that, hey, this is a very smart agent altogether, right? The reason is very simple. Here also you'll be able to see that what is mainly happening. This LLM plus tool is basically happening, right? Nothing more than that, right? There is this is also a loop that is basically happening over here. But other than that, nothing is happening, right? No planning, no structured plan, no deep reasoning, no state management, nothing, no persistent memory. It's just like giving a request, tools is being used, and this continuous loop is basically happening. Now, in the case of deep agent, now deep agent works completely different, right? Now we are going to see the deep agent, and we don't say this as a shallow agent because this is completely different. Now we'll try to understand how does deep agent work. Now, some of the example of deep agent, we can talk about deep researchers, deep research agent in ChatGPT, Claude, and I hope everybody has also heard about Manus AI, right? And we are also coming up with a product which is called as Zenodox, and there also we are developing this deep agent, okay? And we'll soon announce this particular product. A lot of development is basically happening. Now, in the case of deep agent, how it is different from the shallow agents that are there, right? So here the architecture will be completely different. So here, let's say that I have a deep agent, okay? This deep agent is basically having 4 important properties, okay? One, this, second, this, third is this, fourth is this, okay? And this 4 important properties actually talks about the characteristics of the deep agent, okay? So the first important property is something called as, it has a planning tool, okay? So whenever a query comes, it is not directly going to hit the, it is not directly going to hit the any kind of a tool or give you the direct output. First, there will be some kind of planning tool. Okay. And then the second will be something called as subagents property. Third is something called as system prompt. And the fourth is basically called as file system. Now we need to understand this. What are these four important properties or core components we can basically say? These are the four core components of a deep agents. Okay. Now, in order to make you understand, I will take an example of cloud code. Okay. So if you know how cloud code is basically used, this is actually a very good, amazing, deep research agent. And if I show you, right, with respect to the cloud code, right, uh, first of all, in order to develop this deep agent, there will be definitely a system prompt. So one of the system prompt that I really want to show you is over here. See, system, you are Cloud Code, Anthropic official CLI for code. You are an interactive CLI tool that helps user with software engineering tasks. Use the instruction below and tools available to assist the user. Assist with defensive security tasks only. Refuse to create, modify, improve, or code that may be used maliciously. See, this is the entire prompt, right? System prompt that is specifically used in Cloud Code, right? And this isn't amazing. See, it is basically visible to everyone. And people definitely use Cloud Code for most of the tasks. Initially, we thought that they are just specifically using for coding tasks, because in this Cloud Code, you have planning functionalities, you have decomposing functionalities and all, right? So I will go back again over here, right? So whenever we talk about what is this planning tool, so whenever a query comes, right, the first important module, that is nothing but planning tool. Now, planning tool is nothing but some kind of planning will happen over here. I'll give you 1,000 feet overview so that everybody can understand. Some kind of planning will happen. Usually in Cloud Code, the planning is basically a kind of to-do list. Okay. So let's say I give a task. I give a task saying that, hey, I want to book a holidays plan to Paris in the budget of let's say 100k rupees. Okay. And I want it for 3 nights, 4 days. Okay. So this is the entire query that I've actually given. Now what will happen is that there will, as soon as I give this query to my deep agents, the first thing is that the planning will happen. Planning basically means we are just going to go ahead and do a to-do list. To-do list, like how we are going to cover this or how this entire plan can be made. So first of all, let's say that the first day is basically to travel to Paris, stay in this particular hotel, the price is so and so. Second day, breakfast have over here, go and visit Eiffel Tower. The third day will be go and visit some other place, see something, and then fourth day come back to India, go to flight, and this is what is the cost, everyday cost. So this is a to-do list, and we will basically have what to book, what not to book, each and everything, right? Then after this to-do list is given, we go to the second important component that is called as subagents. Now what is subagents? Because this to-do list needs to be executed by someone, right? So what we'll do here, we will create subagents. So this will be my subagent 1, which will be making sure to execute this first to-do list. Then again, you'll be having the subagent 2, then subagent 3, then subagent 4, right? So based on this particular to-do list, we definitely want so many agents, right? And based on this particular agents, these agents will be responsible in solving this specific task. Okay. Now to solve this particular task, we also require system prompt, like how my agent should basically behave. This system prompt I already showed you with respect to the Cloud Code, right? So here you can see clearly how this system prompt looks like, right? So you'll have some tone, coding style, anything, whatever things you really want to probably go ahead and put it, right? Then comes the file system. Now file system is very important. This file system is basically a place, a persistent memory. You can basically say this like a persistent memory, which will be accessible to all the subagents, right? Which will be able to accessible to all the subagents. And now these subagents can probably do any kind of task, save it in this persistent memory, which will be in the form of a file system. It can be a specific file, it can be a shared memory, it can be something, right? And all these specific agents can basically communicate with each other. So here you can see that it's mostly a kind of planning, creating subagents for solving tasks, having a system prompt, and using a file system, which is a kind of a persistent memory between all these particular subagents. And this is how a deep agent will be able to carry out any other task and generate the output. Now, one specific example that I'll give you. Let's say that I say that, hey, I will give you a topic on something. Okay, let's say I will give you a blog topic. You do the research and probably tell me how this blog needs to be generated in the form of output. So what my deep research agent will do, let's say first of all it will see how many, first of all it will make a to-do list, right? Now in this to-do list it knows what task will be there. So let's say the first task is nothing but research of the blog. The second task is do more research, let's say more research from research papers or from some other outsourcing material, something like that. Third is basically to write the blog. The fourth can be copyright check. Okay, now for doing the research, obviously we will going to create a sub agent. Now this sub agent should definitely have the access to the internet. Okay, definitely to the internet. Then more research, let's say this sub agent basically has the access to archive. Okay, it is a research paper, let's say. Then this sub agent will be an expertise in writing the blogs, and fourth will be probably to check the copyright from the internet. And then all the tasks will be parallelly done, right? So I hope you got an idea about how a deep agent basically works. So guys, I hope you have got a basic understanding about how deep agents actually work. Now what we are going to do is that we are going to go ahead and implement a basic deep agent. Uh, and this deep agent will have some more functionalities with respect to tools. But before we start this, I will try to show you from the start, wherein we take a empty project workspace, then we create a virtual environment, then after that we go ahead and install all the libraries, and then finally we go ahead and implement a basic deep agent. Okay, so here is my empty folder that is there. So I've created something called as deep agent course folders, and from this I'm going to go ahead and open my Google anti-gravity. So here is what I've actually opened, my Google anti-gravity ID. You can use any kind of IDs, it is based on your requirement. Okay, and the first thing is that I will just go ahead and open my terminal. Inside my terminal I'll go ahead and open my command prompt. So the first thing is that I need to initialize this particular repository. So for that I'll be using UV package manager. So for that what I'm actually going to do, I'll just go ahead and write UV init. So once we write UV init, you can see that our project workspace has been initialized. Okay, then the next step will be that we'll go ahead and create our virtual environment. So for that, you just need to go ahead and write UV, the virtual environment name. Here I have actually used venv. Now here you can see that once I did this, my virtual environment has got created. So here you can see that your virtual environment has got created. Now, in order to install the packages in this particular virtual environment, first of all, you need to activate this virtual environment. So I've activated it over here. I'll clear the screen. Okay. Once we have activated, we are in the same virtual environment. So what I will do is that along with this, I will go ahead and write my requirement.txt file. Okay. And I will go ahead and write all the packages that I require in order to create a basic deep agent. Okay. So first package that I will be requiring, or library I'll be requiring, is nothing but deep agents. Okay. Now this deep agent is a kind of a standalone library for building agents that can tackle complex multi-step tasks. This entire deep agent is built on LangGraph. Okay, it is built on LangGraph, and it is basically inspired from Cloudy Code, Mano's deep research that is available in OpenAI. All those kind of features. So this deep agents, it is completely built on LangGraph, and LangGraph, you know that it is specifically used for creating multi-complex workflows, right? Multi-AI agents complex workflow. It has all the properties like stateful. It has some amazing data structures, which is called as state, which can remember all the information with respect to the workflows that we have, right? It will be able to share the informations also. So we'll be using deep agents for this. Along with this, I will also be going and installing Langchain. I'll be installing Langchain OpenAI. Since I may use Langchain OpenAI, then I also want Grok. So all these particular libraries will go ahead and install. Along with this, I will also go ahead and install IPyKernel. Now, quickly, let's go ahead and in order to install all these libraries, I'll write uv add -r requirement.txt. IPyKernel is just for attaching kernel to a Jupyter notebook. So that is the reason we are installing this. So here you can see that apart from this warning, I think the installation will happen perfectly. So all the installation has been done by default. When we are doing deep agents, I think LangGraph will also get installed. So here you can see LangGraph is also getting installed. Perfect. So let me clear my screen. This is done. Now, the next thing is that I will just go ahead and create a folder. Let's say this folder name is Deep Agents Demo. Okay. And the first folder is like a basic deep agent .ipynb. Perfect. Now, the first step, we will go ahead and select our kernel. So we have selected our kernel. So I will put some definition over here so that you can refer it whenever you want. Okay. It is up to you. Whenever you want, you can refer it. So here you can see deep agents overview, build agents that can plan, use sub-agents, leverage file systems for complex tasks. You know, I'll show you all these examples as we go ahead. Okay. And, there are some points that I can also provide you over here with respect to this particular theory. Okay. When to use deep agents. This is just for your definition, even though I've explained each and everything. Okay. And here I will just put this information. I know I had to put it earlier, but it's okay. So here you can see when to use deep agents. Use deep agents when you need agents that can handle complex multi-step tasks that require planning, decomposition, manage large amounts of context through file system tools, delegate works to specialize sub-agents for context isolation, persist memory across conversation and thread. Since this is already made with the help of LangGraph only, so I think all these things will be available internally. Okay. Now, let's start with the first code. Okay. Now, I will also be installing one more library, which is called as Tavily Python. Okay, and this will be an important library. I'll tell you just in a while because I'm going to use Tavily. If you have seen in the Langchain module, right, I've shown you how to use Tavily as in the form of a tool with respect to any with integrated with any kind of agents itself, right? So I'll write uv add -r requirement.txt. Okay, once this is done, this is perfect, right? Um, Now, along with this, I'm also going to use some of the virtual environment, variables that I really want, right? I'm planning to use some kind of keys. So that keys, we will try to use it. So right now, I will just go ahead and copy these keys that I require. Okay. I'll create a virtual environment .env file. Okay. And I will use some keys like OpenAI key, Grok API key, Google API key, Tavily API key. So Tavily API key is basically for the internet search. I'm going to specifically use this. OpenAI API key, Grok API key, and Google API key for those specific models. Okay. Now, once this is done, let's start our basic. We'll just go ahead and start with a simple deep agent. Okay. So here I'll just go ahead and write a basic deep agent. Okay. Now the first step is that I will go ahead and import OS. Then from .env. Okay, I have to also go ahead and install this one. Python.env. Okay. We're going to use this so that we can load the environment variables. uv add -r requirement.txt. Okay. So python.env is done. Good enough. So from here, we are going to go ahead and write from .env import load_.env, and we'll initialize this for our environment variable. Okay. Now, along with this, what we are basically going to do is that quickly os.environ. Okay. We are just going to go ahead and import all the libraries that we require, like OpenAI API key, like os.getenv. So whatever libraries I want, I can basically go ahead and use this. Okay. You can also do it for Grok. You can do it for, you know, Tavily, wherever you want, right? So this will be Grok. This will also be Grok, and this will be your Tavily. Let's see, Tavily. Perfect, right? So all the environment variables has been done, right? Now, first of all, before we use Tavily, I really want to load our Tavily client so that we can do or we can integrate that tool with our deep agent, right? So for that, what we are basically going to do is that I'll just go ahead and import from Tavily, import Tavily client, and here we are going to go ahead and initialize over here with the API key. Even though I've set it up, here you can write os.getEnv, and here we are going to go ahead and use my Tavily underscore API key. Okay. How to get this Tavily underscore API key? It's very simple. Just go over here, go to the browser, search for Tavily. So Tavily, if you don't know, guys, it provides you like an internet search. It's a real-time internet search. You can just go ahead and log in. Once you log in, let's say I'll continue with Google. Once you log in over here, so here you can see that first of all, you'll be getting the key, right? You can just copy this and you can use it. So this will basically be my Tavily client. Okay, Tavily underscore client. Once you have this, we will use this client in a tool. Okay, in a tool we will specifically use it, and this tool will be using this. So that tool that uses Tavily client, it's basically an internet search tool, right? So here I will go ahead and create a definition which is called as web search. Definition web search. Here I will give my first parameter as query str, which will be a string type. Let's say the max number of results is equal to a colon int is equal to 5. Let's say I want a maximum results of 5. I can also give topic as a parameter because I'm going to use that topic over here, and we'll be using literal. For this literal, I'll just go ahead and import from typing import literal. Okay, from typing import literal. Here is my literal over here. We have imported it. Let's see whether this will get imported or not. Yeah, so perfect. So this topic will be nothing but it will be a literal, and literal over here we can give a list of values. Let's say I want sports news, and I want news, I want finance, some of the categories that we are specifically using. Okay, and by default, I can just say that, hey, topic will be by default sports news, or I can also say general. Okay, something like this. So in short, what we have done is that this all parameters is basically required by the Tavily client. So that's the reason we are hard coding over here with all the necessary options. Okay, and then finally I will also go ahead and say one more parameter, which is include raw content, which will be equal to boolean value, which is nothing but false. Okay, so these are all my parameters for the web search. And remember, these all parameters are required by the Tavily client. So that's the reason we are mentioning over here. Okay. Now I'm going to basically run a web search. Okay. Run a web search. So here are all the parameters that we have mentioned. Let me write it in this way so that you should be able to see the parameters in a better way. So 3 parameters are there inside this web search. Okay. Okay, perfect. Now, what we are basically going to do, we are going to just use the return Tavily client dot search with all these parameters that we have given. One is query. Okay. Then I'm also going to go ahead and give the max results. Spelling is wrong. Huh? Max results. Okay. Max results. Then The third parameter that we are going to basically have is include raw content, and then we can also give the topic. Okay, so all the parameters is basically given over here. And remember, sometimes you have to make sure that please go ahead and see this Tably client, because there will be a set of parameters that will be specifically used, right? And that parameter should be in a same order, right? So here, if you see, this is the parameter for max results over here. This is for the include raw content is equal to this one, and this is finally for topic. Okay, sometime if the order is changed, you may not get the output properly. Okay, so this is done. Here you can see that I've actually given all these things, and finally we do a web search. Okay, so here you can see that this is my web search functionality, and this is basically returning just a query that we have actually done in the internet with the help of Tably client. Okay, now these are my tools that we are going to use. So this specifically we are going to use as a tools, and this tool is nothing but for the internet search. Now you may be thinking, Krish, how did I decide the parameters and all? It's very simple. Whatever Tably client actually requires, I saw the documentation page, I understood, okay, these are the parameters that is required. I can give all how many number of literals I want. Okay, literals basically means like what all categories of news I specifically want from that internet search, something like that. Okay, so I'll be executing this. Now the next step is basically to create a deep agent. Okay, now to create a deep agent, it is very, very simple. Very simple. First of all, we go ahead and start with a prompt. Okay. We go ahead and start with a prompt. Now this prompt can be a simple prompt. It can be a complex prompt, right? And the next thing is that we go ahead and define our agent. Now for defining an agent, it is we need to import, like how do we create an agent? See, in Langchain, we have something like this from Langchain.agents import create or import. In Langchain agents also, I think we have create agent, right? Now, when we are using this create agent, this is a agent wherein you have an LLM, you have a option to integrate with the tool, right? This is how we basically create a agent using Langchain. But whenever we want to create a deep agent, for that we will be importing from deep agents, import create deep agent. Okay, so here we use create deep agent. Okay, this is what we basically use in this scenario. Okay, now this create deep agents requires some of the parameter. Now what are parameter it requires? First of all, it requires something called as tools. Now tools we have actually created. What is the tool that we want? It is nothing but web search, right? That is a functionality. Second is system prompt. We specify some kind of system prompt. Now let's say that I'll say, hey, act as a researcher. Okay, act as a researcher. And here I also have one more parameter which is basically called as model. Okay, now why do we basically require model over here, right? Model is nothing but, if you see with respect to create deep agent, right, here we need to provide a model. See, model is equal to string. Now which model we are basically going to use, right? What model you are going to use, whether you want to use OpenAI, whether you want to use Grok. So let's say that I go ahead and create one thing over here. I'll say, okay, I've imported Grok API key. Now with respect to the Grok API key, how do I load the model? So I can go ahead and write from Langchain dot chat model, right? I can basically go ahead and write Langchain dot chat models import init chat model, right? Now init chat model, I will just go ahead and initialize it over here, right? So here I can basically specify Grok model, whichever Grok model I want to use it, because I've already imported it, and the model name, right? So for importing that also, it is a very simple task. It's not a very complicated task, because we have learned that many number of times, right? How to import things, how to get the Grok API keys, and everything has been mentioned or explained it in a very clear manner beforehand whenever we discussed about the Langchain module also, right? In the Langchain module, we saw that how to basically go ahead and integrate different types of model also, right? So let's say that this is my model over here, And here I've written grok when 32 billion, right? So this is basically my model. And the same model, okay, so here spelling mistake is there, no worries. So here I will just go ahead and execute it. So this is my model, right? And here I'm going to use the same model over here, right? So once I do this, I think I should be able to execute it. So let's see whether we'll get any error. So this becomes my deep agent. And we'll also display this deep agent, how it looks like. See, how to create this model, you know, various ways. You can use init chat model, you can specify OpenAI, you can specify Google Gemini models, or you can also use chat grok, you can use chat OpenAI, you can use chat Google Gen AI, anyone, right? And then you can specify over here. Now I will just go ahead and create my deep agent. Let's see what we will be getting. Okay. This will take some time to create this. So it is giving me an error saying that a keyword argument models. Did you mean model? So fine, I'll give model. Now this kind of errors you will be seeing. Now see, what is the differences between a normal agent, right? You know how to create a normal agent. So in order to create a basic agent, how do we import it? So I'll write from Langchain dot agents import create agent, right? So if you remember, simple agent, if I use create agent over here, and if I give the model as model is equal to model, right? And let's say the tools, or let's just print this, okay? So this is my simple agent. Now in the case of simple agent, you can see that, okay, right now I did not add any tools. So let's say if I go ahead and add tools, tool is equal to web search. So here you can see, okay, did you mean tools? Okay, yeah, I have to say tools. Now see, now this was how a basic AI agent looks like, and this is how a deep agent looks like. Okay, now what is the difference? See, almost everything is same, right? Here also you have a model, you have integrated with tools, right? Whenever we talk about deep agents, right? Here we also have some of the middlewares attached, right? And if you have seen my Langchain module, right, you should understand what middleware is all about, right? In the middleware, you have hooks, right? You have hooks over here. You can see there's a part to tool calls hook. There is a summarization tool call hook. And after the model, there is a to-do list. So automatically to-do list is basically getting created. This to-do list is basically used for by the deep agents to track how the execution is basically going on whenever a task is assigned to the entire deep agent, right? When the task is assigned, automatically a task is divided into subtasks, and every of the tasks needs to be tracked, and that is possible by the to-do list. And when the conversation is continuously going on, their summarization will automatically happen, right? And if you remember in the Langchain module, I've discussed all these things like about the middleware. It is just like a kind of a hook which you can integrate in between on a specific workflow. So this is the basic difference over here, right? Now, whenever I use this deep agent and I try to execute anything, okay, how do I execute it? So what I will do, I will take this same deep agent and I'll say result is equal to, and I'll use agent dot invoke. So let's say that I will use the same agent. So I'll use deep agent dot invoke and I will go ahead and execute it. So how do we go ahead and execute it? So here I'll give my messages key, okay. And in the messages, the first thing that I really need to specify is nothing but role. So I'll go ahead and write role colon, role colon user, okay, role colon user, and then I will be specify content colon, let's say the content will be what is LangGraph. Okay, now when I'm asking this question, understand, here you should know that how deep agent will be executing this. Okay, so when this question goes over here, right, it goes over here, it sees whether we need to make a part tool call or not. Now I'm asking what is LangGraph. Okay, I'm asking what is LangGraph. So it will, what it will do, it will go ahead and do a quick internet search. Okay, or I'll just go ahead and ask what is deep agent. So finally, if when I execute this, what is LangGraph or what is deep agents? Let's say I'll change my question, right? Now see how this result will basically get displayed. So internally, deep agent is just going to follow this entire workflow, right? And wherever it requires this specific hook, that will be used, like summarization, like to-do list, right? So as soon as the input goes over here, the model is again going to make a to-do list, like how to resolve this particular question. It will divide that into subtask, and internally, it is also going to hit the tool. This tool is nothing but the internet search tool. When this tool goes back over here with respect to the context, it is also going to do the summarization. So here, I think after some time, you are definitely going to get the output. And I will also show you with the help of streaming also how we can go ahead and do the same thing. Okay, because we also need to go ahead and apply the streaming. Because right now, deep agent usually take a lot of time with doing the lot of research, finding out how many different types of outputs, like proper research if it is doing the internet research itself. So here you can see that deep agent is an end-to-end deep learning project. So here you can see it has also created files, right? So this kind of files that you'll be able to see, right? So let's do one thing. Okay, so I will just go ahead and display the results, messages. So this is the real output, uh, -1 dot content. Okay, so let's see. So this is the output that you'll be able to see over here. Okay, deep agent is an end-to-end deep reasoning agent introduced by so and so, and this is your enter output with all the details that is basically coming from the internet search. Okay, now along with this, if you want to get more information, I will also go ahead and write result of files, and let's see this files. Okay, so here you can see large tool results, content, query department, follow-up questions, all this information, results, URL. So these are some more additional information that you'll be seeing, title, deep agent, all this information, right? So it is also getting this specific information over here, right? And these are some of the files it may have created in some format, so that it will be also able to preserve the context, because it is doing this kind of summarization also. And sometimes, if the context size is very huge, it will also make sure to probably internally create some kind of content in some hard disk file, right? Like it can be a txt file, it can be some different kind of file. So that file information is basically created over here. You can see it has created, it has been modified at this specific location and this particular time. Okay, so everything is basically done, and this is how a simple deep agent actually work. Okay, here you get a clear idea like what a deep agent is all about. Here you can create any number of tools. We have also seen that how a simple agent is different from a deep agent. In deep agent, automatically there are a lot of middleware hooks that has got applied, whereas in a simple agent there are just modules, like there are just nodes, there are graphs, there are edges, which are communicating with each other. Yes, you can also go ahead and customize this simple agent with multiple middlewares, and you can add those kind of hooks. Okay, but this gives you a clear idea about like how a deep agent basically works. So guys, I hope you have understood the initial part of building deep agents, but there are still many topics left. And I don't want to make this video much more longer. So this was the part one. Now in the part two, we will try to do some customization in our deep agents, so wherein we will be using model, system prompt, tools, and then there are also some more features with respect to backend, subagents, and interrupt. So we will try to cover all this specific topic in the part two. But I hope from the part one, you have clearly understood how to work or how to build a basic deep agent, wherein you have tools, right? Similarly, you can develop any number of tools. You can integrate with this specific deep agent, but understand at the end of the day, when you're using this library, it's more like you're building something that internally does a lot of steps for completing the entire task, right? So yes, this was it from my side. I will see you all in the next section, wherein we will be discussing about customizing deep agents. Then we'll understand about backend, subagents, and many more. So guys, now we are going to continue the discussion with respect to deep agents. And recently, there is a lot of updates that have specifically come up in deep agents in the Langchain documentation. Now we are like all the series of videos that are probably going to come up, we are going to understand about how we can customize deep agents to do various complex tasks. Okay. Now you'll be able to see that one of the example over here, whenever we are using this create deep agent function in order to create a deep agent, there are a lot of different parameters that you'll be seeing over here. There are parameters like model, like which model you can specifically use. There is something called a system prompt. There is something called as tools, different kind of tools you'll be able to use. Then there is memory, skills, backend, permissions, subagents, middleware, interrupt, and so many different options. Now, with the help of this specific options, you will be able to create a very good deep agent wherein you can add multiple amazing, you'll be able to add multiple amazing features, which includes like additional context engineering. You'll be able to add additional skills and all, right? So as we go ahead, we will be learning each and every of this specific parameter in detail. And the best part about this is that the documentation, you'll be able to see there is something with respect to models, how to perform context engineering. Then you have something called as backend, subagents, human in the loop, permissions, each and everything is there with respect to memory. So we will go ahead and develop each and everything over here, and I'll try to show you that how we can actually go ahead and customize your deep agents by implementing all the specific features. Hello guys, so we are going to continue the discussion with respect to understanding about deep agents. Already in our previous section, we have already seen that how you can go ahead and create your own deep agent. We had also integrated with some of the tools, and we also saw that entire agentic loop, like how a deep agent specifically works. Now, in this video and in this series of videos, in the upcoming series of videos, we are still going to deep dive into deep agents, and we are going to understand some more topics out there. Okay. Now, before I go ahead, I really want to show you one very important topic. Okay. So here you can see that with respect to deep agents, right? Deep agents will be able to do a lot of tasks, right? If you consider an example with respect to Claude or OpenAI Codex, right? Or if you also consider Claude Code. So internally, they all specifically use something called as Claude Code SDK or Claude Agents SDK. Okay, so this, if I probably talk about, let's say if I'm, and I hope everybody may be knowing about Claude, right? Claude internally, it's Claude Chat, Claude Code, internally specifically uses something called as Claude Agent SDK, right? Now, this Claude Agent SDK is just like a specific deep agent which will be doing all the specific task. Okay. And that's the reason why I'm making this particular series. You really need to understand how you can also build your own deep agents with the help of open source libraries like LangGraph, Langchain, and all, right? Now, when we talk about all the specific deep agents, you will be seeing that internally it will have all the specific functionalities like planning. It will be having an option of creating subagents. It will be also able to read and write and manage access files within the directory, prompt caching. It will also be able to run with respect to sandboxes. It is just like an isolated environment. So if you see as an example of Cloud Code, right, it runs everything just to verify within its internal sandboxes itself, right? So we will be talking about all these things, right, as we go ahead in this particular series. Then you have something called as memory. We will be talking about different types of memory that is available in deep agents, right? You can store and retrieve information for contextual awareness. There is a topic that I will be covering which is called as contextual engineering or context engineering, right? We will be talking over there about this specific memory, right? Then you have something called as skills, right? Skills are nothing but extended capabilities with domain specific skills and tools, some kind of common functionalities that allows the deep agents to work really well, right? And then you have something called as summarization. So these are some of the hardcore topics that I've specifically defined over here, which every deep agents actually can do it at much ease, right? Similarly, Claude will also be able to do it because internally it actually uses something called as Claude Agent SDK. Now let us go ahead and try to understand the differences between these deep agents that is being provided by Langchain versus this Claude Agents SDK. Right? We'll try to just find out a difference, what exactly it is different, how it is different. Because if you understand this difference now, you'll understand why understanding how to probably go ahead and create deep agents is important for everyone. Okay. So here you will be able to see that I have created this specific image. Again, I have used ChatGPT for generating this image. But the main core idea is basically to understand what is the differences between deep agents versus the Claude Agent SDK. So first, the primary goal is that it will be helping us to build long running multi-agent workflows. Okay. Similarly, here, Claude Agent SDK, you can see it extends Claude codes to build powerful agents. Okay. Foundation over here is actually LangGraph and Langchain. Here, the entire Cloud Code infrastructure. What all model this deep agents can specifically support if you're using Langchain? Okay, it supports OpenAI, Anthropic, Gemini, Grok, local models, different kind of models, but this is specifically to Claude models, right? When we talk about Claude Agent SDK. Yes, now there are options wherein you can also go ahead and launch Claude Code with Olama and all. Okay. But specifically, if you say, if you really want this Claude Agent SDK to work well, we should use Claude models itself. Okay. The core strength is multi-agent orchestrating and planning. Here you will be able to do tool use, runtime, development, developer productivity. Sub-agents, you are having an option, right? Here to create hierarchical sub-agents. Here also you basically have, but it is through Claude runtime. Okay. Then context management. Here you have to specialize, like specifically use different types of memory to make sure to have that particular entire context managed, right? So for that, you need a context isolation. This is basically managed by entire code runtime. Skills, built-in skill system. Here also you have something like skill supports through Claude ecosystem. Here you can go ahead and create your own skills. I will be talking about all this specific thing. You also have something called as hooks and events. Here also you have powerful events driven hooks. MCP support, both of them are basically having. Then you have core design principles, all these particular features like human in the loop, observability, best use cases, vendor lock-in. Almost every both of them has, but with respect to Claude Agent SDK, they have their own runtime, right? And since this is an open source, we will try to see that how we can actually implement it. So in all this series of videos, we are going to take one by one topic. We are going to cover each and everything as we go ahead. Okay. So the deep agent architecture for any kind of task will look something like this. The user will send a task, the supervised CEO agent, like this will be an agent. It will go ahead and probably assign it to sub agents and all. And then finally, it may use different kind of tools, memory, vector stores, API databases, right? And this is how the Cloud Agent SDK architecture looks like. Now, obviously, there's so many topics that I'm actually talking about, and it is better that we cover one by one. Basic part we have already covered, but let me just show you a specific demo. Okay. And this demo will definitely help you to understand more about deep agents. Okay. So let's say here I'll ask a question. What is LLM gateways? Okay. What is LLM gateways? Do the web search and provide me the result. Okay. So this is basically Claude AI. Okay. I'm not even using Claude Code. So here you'll be able to see that this is basically going to do the search in the web, right? It is planning, it is doing all the search in the web and all. And there is also a feature which is basically called as research, right? If I go ahead and click on this research, and if I go ahead and ask the same question, okay, now it is going to do some additional research over here, right? Additional research. So here you will be able to see that before doing a web search, it will probably go ahead and ask multiple questions over here, search the web, and it will probably do that entire planning, and then finally it will probably go ahead and show you. I just want walk through this with your previous, so I don't want to repeat that. So see, it has been able to decide it, even though it gave the answer over here. I said that okay, do the web search for provided for me, and probably when I ask the same question, it is able to see that okay, fine, I've already given the answer. It is giving me the same answer over there. You can go ahead and check it out. Now this is what I have actually developed. Okay, and this is directly with the help of Langchain deep agents libraries, right? Now let's say I'll go ahead and ask what write me a provide me a okay Python code Python code Python code to to do binary search. Let's say this is my question that I've asked. Okay. Now the most amazing thing is that here that you have some kind of models. Let's say I will go ahead and use GPT-4o Mini, any specific models that I really want to use. Then you have multiple skill sets. See, and there is also something called as memory over here, which is like an agent.md file. Okay. This agent.md file will always get loaded into every turn the agent operating. Basically, whenever you go ahead and ask a question, first of all, whatever information is basically available in this agent.md file, it will be loaded along with the prompt. Okay. Then you also have different skills. The skills are like having different uh, capabilities which the agent can specifically use to answer some of them. Let's say one of the skill is something called as Python skill. Okay. Here the Python skill has information: write clean, correct, runnable Python code for any coding request. Okay. Use whenever the user asks you to write, implement, fix, and all. Right. Now, when I'm asking this question, provide me a Python code to do binary search, the first thing that will happen, it will start planning. Right. It will start planning. The agent will start planning. This deep agent will start planning. And first of all, it will load whatever information I've written inside this agent.md file into the context. And then finally, it will go ahead and call this specific skill because it knows that it has so many skills. Now, I will, and after probably calling the skills, you will also be able to see that there is something called as report writing. There is something called as LangGraph docs. So this is something called as context. So I have created different skills for different purpose. Don't worry, I will be teaching you how to develop this particular skills. But right now, I just want to show you the demo how things work. Okay. Now, once I go ahead and execute over here, provide me a Python code to do binary search. See, now it is thinking, planning, right? It is using the skills, tools. The best part about deep agent is that it starts thinking, and based on the necessary context that it probably gets, it will be able to provide you much more amazing information, right? So now here you can see the agent activity. Now it is basically doing a write file path. So this is just like a it is trying to probably go ahead and write some content over here, and that's the reason you are able to get this entire information. See, it started thinking out there. It started planning based on the memory and skills that were available. Okay. Now I will go ahead and ask what are LLM gateways, and write me a detailed report about it. Okay. Now see, this is my next question that I'm asking. Now it has started thinking. Again, it is planning. It is using the necessary skills along with the memory, along with the tools internally it may have. Okay. Here I have also given something called as web search tool, the web research tool, right? Now it is planning all the specific information. Obviously, I can't see more details over here, but I think there are options to probably display those information also, right? So now, once this entire planning is basically done, you should be able to get an LLM gateway. And internally, again, this report writing skills will be called. Because here it shows that it is formatting a quality rules for turning research findings into a clear citable report, right? So over here, you can see that the deep agent is specifically doing all the task that is mentioned over here, right? Planning, it may want to probably go ahead and create sub agents. I will also show you how you can go ahead and internally create sandboxes and all, right? Step by step, we will be covering all this specific topic, right? And this is the kind of projects we'll be developing till the end of the session, right? And this projects, here you'll be able to see, first of all, we will talk about memories. Now see how amazing output I've actually got, right? Task, you can see conduct through research on LLM gateway, including this. Then LLM gateway, all the information is basically gone. And internally, I will also show you that it is calling this specific skills. Okay. So all these things will be there. I think it should be able to also give me the answer, which all, let's say I'll ask which all skills you have access to. Okay. Access to. So if I go ahead and execute this, let's see whether it will be able to get all the skills that it has. See, I have access to the following skills: context engineering, principle, checklist for structured agent context, including system prompt. So all the skills is available. These skills enable me to assist effectively in the range of tasks such as coding, research, and report writing. All the information is basically given away, right? So now what we are basically going to do is that we will try to understand and see that how we can implement all these things as we go ahead, right? And I've created multiple images. See, we'll talk about what exactly memory in deep agents are, what exactly skills in deep agents are. So there are a lot of topics that are specifically going to come up. Hello guys, so we are going to continue the discussion with respect to deep agents. In this particular section, we are going to discuss about a very core topic, which is basically called as backends. So first of all, we'll try to understand what are backends, and then we will also try to implement it different types, again with the help of practical implementation where we are going to use Langchain. So let's go ahead and discuss about it step by step. So first of all, whenever we talk about backends, what exactly this backend is, okay? So let's say that we are developing a deep agent. This deep agent specifically works with a very important thing which is called as virtual file system. Okay, virtual file system. Now, since we have this virtual file system has various tools. Okay, and this tools helps you to write files, read files, even edit files, and along with this you'll also have various other uh, tools available within this virtual file system. Okay, and whenever we talk about backends, what exactly backend is basically doing? See, backend is it's simply the component that will specifically answer a question. Now let's say if I say the deep agent, hey, go ahead and probably create a file which is called as todo.txt and write some content within this particular file. Okay, so when I'm asking this question to the deep agents, right, the major question comes is that where this deep agent is going to write this specific file, right? Where it is going to write, whether it is going to write in the RAM, whether it is going to write in the hard disk, or where it is specifically going to write. Obviously, it has all this virtual file system, right? And it has all the commands to write the file, read the file, edit the file, delete the file, and do multiple tasks, right? Search for the file and all, right? All these things are available, but still the question is coming that where do we go ahead and create this particular file, right? And that is where your backend comes into picture. Backend is simply the component that answers the question where the agent, that is this deep agent, writes the file, what really happens, for this particular file, and where does it go, right? Does it get saved it somewhere? Okay, we can just make a list of question like different backends give you different answer. Let's say RAM, you want to save this particular file in the RAM, so deep agent will go ahead and save your file in the RAM. It may probably want to save a file in the rail hard disk. It will go ahead and probably save it over there. Or it may also go ahead and probably share it in some kind of shared store, right? So all these questions are specifically answered by the backend. So here you can see that this virtual file system is there. Backend is like an abstract access to different execution environment and resources. This backend probably can save it in a file system, it can save it in a store, it can save it in a context hub, it can save it in a state, it can also create a separate sandbox environment so that it can probably go ahead and execute things. It can also probably use this local shell and execute different types of commands even on a local machine. And that is what a deep agent is all about. Because if you see deep agent, if you see Claude SDK agents, if you have used Claude code, what it does, it also internally uses some kind of local shell which will run different kind of shell commands. It may try to install some of the libraries in a specific virtual environment. It may do multiple things, right? And that is what backend is all about, right? But still, the question comes is that what are the different kind of backends we specifically use? When do we use what kind of backend? Usually, if you really want to understand over here, we have different backends. One is with respect to file system, one is with respect to store, one is with respect to context hub, one is with respect to state backend, right? Along with this, you also have something called as local backend, right? And these all kind of backends will be used definitely for different purposes. Okay, now let me show you a very good example so that you clearly understand that how does backend actually work. Okay, so now first of all, what I will do, I will just go ahead and create a file. Let's say this file, I'll just go ahead and write 3 backends.ipynb. Okay, and I will just show you multiple examples of how you can specifically work with backend. Okay, now the first thing first, whenever you are working, the major thing that is specifically required is that at any point of time you need to go ahead and import all your important libraries that is specifically required. Without that, you will not be able to do anything, right? So here, first of all, I will go ahead and add a code wherein we are importing OpenAI API keys, we are importing Grok API keys, we are importing Tavily API key and all, right? So guys, now once we have imported all the libraries, the first type of backend that we are going to specifically discuss is about state backend. Now, what exactly is state backend? And if you also see in this diagram, you have one of the backend types which has the access of the virtual file system, which is nothing but state. And here it is written maintain backend state and metadata. Okay. Now, in order to understand the state backend, the virtual system in this particular scenario lives in the LangGraph state. Okay, LangGraph state. So let's say that whenever you create a deep agent, the deep agent internally is basically a kind of LangGraph agentic workflow, right? And whatever information, whatever files we really are saving by using this state backend will be only saved inside this LangGraph state. Okay. And remember, this LangGraph state, with respect to any information that is saved, will be available throughout that entire states with the same thread. Okay. So with the same thread, when you're having the conversation again and again with the deep agent, uh, you will be able to get that specific information out there. Okay. I know this is a little bit of confusing, but let me show you with a practical example and let me show you how you can go ahead and implement it. Okay. So quickly, what I will do in order to show you an example out there, uh, first of all, I will just go ahead and create a deep agent. So for creating a deep agent, I will be importing these three libraries. From import OS, import from deep agents, import create deep agents. And then we are also importing state backend. Okay. Now this state backend understand that whatever deep agent we are creating, all the files, let's say if I tell you, if I tell my deep agent to create a file, right, that will be saving in the LangGraph state. And when that agent execution is completed, when that agent work is done, when that agent session is closed, automatically that entire file will be deleted. Okay. So over here, you'll be able to see, I will be going ahead and creating an agent. So this will basically be my agent. So let's go ahead and create the agent first of all. Okay. So I'm creating deep agents over here, create deep agents, and I'm using the model GPT 5.0. If I, and again, basically I want to go ahead and create something, right? I want to probably go ahead and create a file, right? And remember, over here I have not specified the backend, but if I really want to specify the backend, here there will be an additional parameter which is called as backend is equal to state backend. Now this state backend, when I specify, right, this is basically saying that all the files that is going to get created inside this particular LangGraph agentic workflow or by these deep agents will be saving those files within the LangGraph state. Okay. Both of this code are same. That basically means if you don't give any parameter, by default, it is going to consider the state backend. Now, the main thing is that I will try to show you an example how these things actually work. Okay. Now, let me go ahead and invoke something. Okay. Invoke. So here I'm invoking the agent and I'm asking it to write a file. I'm saying that agent2.invoke messages role is equal to user content. I'm saying create a file at notes to do.txt with exactly this content, record video, edit video, upload video, then tell me you have done it. Okay. So I'm saying that, hey, go ahead and create this specific file with this specific content and just tell me after it is created. Now, your major question should basically come where it is going to save this specific file, where it is going to save this notes slash to do.txt. We also don't know that. Okay. So let's see. And by default right now, this agent is basically using the state backend. Okay. And this state backend basically also has, this agent has the access of the virtual file system. And once it creates this file, it is going to save it within the LangGraph state so that we will not be able to find this file physically over here, but instead this is getting internally stored in the LangGraph state, which is in turn storing it in the RAM, right? Once the agent is basically deleted, once the agent is closed, that automatic those file will also get deleted. Okay. Now let's go ahead and see what will be the output over here. Okay. So I will execute and I will also go ahead and see the content. Okay. So here you can see clearly I am trying to execute this. Okay, I'm trying to execute this over here quickly. And here you can see it has created the notes/to-do.txt with the exact required content. Now you may be thinking, Krish, it may have got created over here. You can see there is no notes folder, right? So this has been but directly created within the LangGraph state, which is stored in the RAM. Okay. Now the next thing is that how can we check? How can we check whether where those files has been created or by which keys those file will be available, right? So that we can basically check whether the backend is working. So here you can see check the backend is working with state backend written files appears under the result files. So if you just go ahead and add a code over here, result, and just see it, right? So there is something called as files, and this file is basically created over here. And the best part about this particular files is that this is basically stored in the LangGraph state. So whenever you specify files internally within that particular deep agent, that files are basically stored in the LangGraph state. So what you can actually do is that here you can give one more additional part like this file is equal to that file information, whatever file information that you really want. Okay. So this way it basically gets stored in the uh, state backend, that is the LangGraph state. Okay, so here you can clearly see that my file is available. If I want to read this particular file, if I want to read this particular data, I will go ahead and just read it. This is the code result.get files, and I should be able to read it over here. Okay, amazing. Yeah. Now let me prove it. Okay, let me prove by one more amazing thing is that I will try to read the file again from that same state, so that you'll just get an idea that it is, if you are executing it with the same thread, you should be able to read those files also. So here I'm using agent.to invoke messages of result of message. I'm saying read /notes to-do.txt back to me. Okay, and here I'm giving that files details. See, files is equal to result.get files, and this is basically happening in the same thread. And once I should be able to read this particular file just from the agent itself, right? So this was about state backend. Okay, now if you go back over here and you can see the content is basically displayed. Now the second type of backend that we are going to use is something called as file system backend. Okay, now what exactly file system backend is? It is very simple, guys. In the case of file system backend, in the case of file system backend, I am going to save, whenever I say any of my deep agents to create a file or do anything, it is going to probably go ahead and save it in the root directory, basically in the hard disk. Okay, now in order to create it, first of all, what I will do, I will go ahead and import that, right? So for that, I will write from deepagents.backend import file system backend, and then I will go ahead and create my root directory. My root directory will be the same directory where my Jupyter notebook is. Okay, and then I will go ahead and create my agent. So let's go ahead and create my agent. Agent is equal to create deep agent. Okay, deep agent, and here I will be using my model is equal to OpenAI GPT 5.0, and here I'm using the backend is equal to file system backend. The root directory will be root and virtual mode will be true. Okay, so once I have this, this will basically give my agent, and I can also display what my root directory will look like. Okay, so here agent created with file system backend. Now if I do the same task wherein I invoke and I tell the agent, hey, do this specific task. Okay, so here you can see agent.invoke. I'm saying create a file with this and upload this specific content. Now where do you think this file will get created? Let's open Control B. See over here, notes is basically created, and this is my to-do text, right? And here this particular is getting saved in the hard disk. Now automatically we can read directly from the hard disk itself. Okay, so I hope you are able to understand how does a deep agent specifically work with respect to our file system backend. Okay, now what we can basically do is that we can even read this, okay, just to check whether the file is available or not. So I'm writing this particular code. So here you can see from pathlib import path, I'm reading that specific path to-do.txt, and I'm seeing that whether that path exists or not. And here you can see that content is also available. Okay, very simple. And now I will also try to read it from that particular file. Okay, so I will go ahead and create my fresh agent, create deep agent, file system, this. Fresh agent, read the node slash todo.txt back to me. And here you should be able to see this. So I'm just trying to show you, by understanding all these things, you should be able to get a clear idea that how our backends are specifically working. Okay. So this is one more perfect example. Now, let's go back and let's see the next type of backend, which is called as store backend. Now, in order to understand about the store backend, so store backend fundamental is very, very simple. Okay. It is going to create a persistent key value or object storage. Okay. So let me go back over here. I will create a markdown with some explanation. Okay. It creates a deep agent backed by a LangGraph store. So since we are using libraries like LangGraph, it will actually be backed by a LangGraph store where it will create a key dictionary values and it will save all the information out there. Okay. Now, in order to do that, again, just see the code. Okay. I have already written the code. No need to write it again and again. So I am specifically using this. So here you can see store backend is there, and we are creating something called as demo user, and this is my store in memory store. I'm using that same store over here, agent store created with store backend plus static, okay, namespace. And now you can read this, and the best part will be that you will be able to create this with one thread and also read it with another thread. Okay, so that's the most important thing, because different thread can probably read over there and get a context over there. Let's say two sessions are currently going on. One session can also be able to read it directly from the in-memory store, right? The other thread should also be able to read it. So here you can see that I've created a thread and I'm saying that, hey, create a file, this, and it should automatically go ahead and create a file. This time it is going to create a file in the in-memory store, which is a kind of a database, a simple database, which will be able to save the information. Now, can we read the same thing from thread 2, right? So I will go ahead and create my another thread and see, read the node to do.txt back to me. And I'm giving the config is equal to thread is equal to 2. So once I basically do that, you will be able to see that I will be able to get all the values, right? So this is the most amazing thing. One thing you really need to know, right? With store backend plus in-memory store, the file is not saved to disk at all. It lives in RAM inside the in-memory store object as an entry keyed under the namespace. This is the most important thing that everybody should know, okay? Now, one very important key description also, I want to put it in front of you so that you get to know about what exactly are the deep agent backends, right? Every deep agent works with a virtual file agent, tools, reads, write using a file, but does not. But those parts are an abstraction. The backend decides where the data physically lives, right? So based on that, but default one is state backend. Then you have file system backend, store backend, right? There is also a different kind of backends, but right now I don't want to teach you that, because there is something called as composite backend, also context hub backend. It will share and retrieve context across runs, which you can definitely go ahead and explore it over here. See, but I'm going to talk about, as we go ahead, I'm going to talk about how to basically go ahead and create sandboxes and all. But there is also one more kind of backend, which is called as contest hub backend, which you can specifically use, right? So this was about understanding about backends, but I hope you got a very clear idea about what exactly backend does. You know, quick comparison, you can see, in case of state backend, it lives in LangGraph state. In case of file system backend, your disk, you can basically do cross thread, survive, restart, Rails, file on the disk. In case of store backend, you'll be also able to use by different threads. Survives restart, unless and until we are not persisting that particular storage, it will not be available. Do we read that file on the disk? The answer is no. Okay. So these are all the informations about backend. I hope you were able to understand about backends very much clearly and how it is specifically used in deep agents. Thank you. So guys, we are going to continue the discussion with respect to understanding about deep agents. In this particular section, we are going to understand and discuss about a very important topic, which is called as context engineering. Now here, first of all, we will try to understand what exactly context engineering is. And along with that, we'll also see that how we can practically implement with the help of deep agent library with the help of Langchain. Okay, so let's go ahead and complete this topic by topic. So first of all, why exactly context engineering is required? Now let's say that you have created a deep agent. So let's say this is my deep agent. Okay, this deep agent has access to tools. It has access to different kind of tools itself. Now context engineering is a kind of is a technique wherein you provide right information right information plus tools plus tools, and that should also be in the right format so that your deep agent can accomplish any task reliably. Okay, so this is really important. So if you are able to provide this deep agent with the right kind of information, right kind of context, along with right tools, right format, then this deep agents will be able to work much more efficiently, right? And whenever we try to work with deep agents, obviously this also has access of various or several kind of context. Okay, now what kind of context, we'll talk about it. Okay, it will also have various kind of access to various kind of context. Okay, let's say some of the context may be required to provide the agent at the start itself, when the agent is about to start. Okay, some context we may provide this deep agent during runtime, right? During runtime we can actually provide, such as when the user is providing the input, right? As you all know, deep agents include built-in mechanism for managing context across long running sessions. This will be working across long running sessions. Then it can actually efficiently use this kind of context to work properly. Okay, now the next thing is that what are the different types of context that are available? Okay, so in order to talk about this, if we talk about deep agents, it has something called as input context. Now, when we talk about input context, usually this basically talks about what goes into agent prompts, agent prompts at startup. At startup basically means when the agent is basically starting, what goes into the agent prompt. Okay, and this has various ways how we can basically set it up. There is one example of system prompt. You can provide a system prompt out there. You can provide memory, you can provide skills, right? We will discuss about what exactly memory is, what exactly skills is. And if you talk about the scope, in this it is basically static and it is applied each run. Okay, applied at each run. Whenever the agent is running, these things can be loaded into the prompt of the agent itself, right? The second important context that we have, the type of context, is that we basically call it as runtime context. Okay, we will discuss about all this context step by step. Okay, the third is something called as context compression. Okay, the fourth is something called as context isolation. Okay, now these are the four types, but I will be discussing one by one. So first of all, we will start with the input context. In the input context, we will see how we can implement it with the help of system prompt, memory, skills, and each and everything. Okay, then as we go ahead, we will be covering the other types of context that are available with respect to the deep agents. Now quickly I will just go ahead and open my the project that we were specifically working on, and then here I will just go ahead and create one more file. So let's say this is my second file that I'm actually going to create, and this I will name it as context engineering.ipynb. Okay, so here we will go ahead and select the kernel. Okay, I will add a markdown, and before that let me see whether my libraries are completely up to date. Okay, so here I will go ahead and write uv add -r requirement.txt. So I think it is already up to date, no worries. Okay, And here inside this particular markdown, I will just provide some explanation about context engineering so that whenever you refer this material, you should be able to get at least the definition. Okay. So here I will go ahead and define this. Perfect. Now let me go ahead and start this. Now, the first thing that I am actually going to implement over here is that, and it's very simple as you have done many number of times. First of all, we are going to load all the libraries that we specifically require, like OpenAI API key, Grok API key, Tableau API key. And I hope everybody knows how to probably go ahead and load this. This is already available in the env file. Now, the first context engineering that we are going to do, right? And as I've already said over here, the first thing that we are going to do implement is basically with respect to input context, right? And inside this input context, we are basically going to use something called as system prompt. Okay, system prompt. And I hope everybody knows about system prompt, right? It is very, very simple. So how do you go ahead and create a deep agent? Now let me go ahead and write from deep agents, import create deep agent. Okay. And here I will just go ahead and create my deep agent. I'll go ahead and write create deep agent. Okay. Create deep agent. The models that we are going to use right over here. So let me close this particular bracket. First, I will be using the model. Let's use a model of OpenAI and the model name will be GPT 5.5. So recent one, which we specifically have. Then you have something called a system prompt. Here we specify the system prompt. Now inside the system prompt, I will be providing a much detailed system prompt, right? And this is what is the input context, right? And here you know that this is just like a static context. So let's say that I will go ahead and provide a system prompt which looks like this. Okay, so here I'll be saying you are a research assistant specializing in scientific literature. Always cite resources, sources, use subagents, use subagents for parallel research on different topics. And here, let me close this still there. Always cite resources, use subagents for parallel research on different topics. So this is basically there. Now I will just go ahead and execute this. And this is what is my agent looks like, right? So here clearly you can see I am trying to give some kind of input context with the help of system prompt. So whenever I go ahead and invoke this, right? How do you invoke it, right? How do you invoke this particular agent? You just go ahead and write invoke.invoke message role content. What is deep agents have written? And this is basically my result, right? So whenever this is invoking, by default, initially this prompt gets loaded out there, right? Loaded out there. And this is just like an input context. And this is static, right? At any time, whenever this agent is specifically called, the prompt is first of all loaded, right? So this is one type of context engineering that we specifically do. Okay. And I hope it is very much clear and you can see that I'm able to get the answer that deep agents can mean different things depending on context. But in AI agent discussion, it usually refers to a more capable long running agent architecture designed to handle complex tasks. So everything is basically mentioned over here, right? Now, what I will do, again, let me go back over here. System prompt is done, but still you can provide input context through some memory or skills, right? So what exactly is this memory? What exactly is the skills? Now we are going to basically discuss about, okay? So here, what exactly memory in deep agents are, okay? So usually what happens is that, and this I really want to show you, right? If you go ahead to the browser, okay? If you go ahead to the browser and if you search for agents.md, okay? Now, what exactly is agent.md? Okay, so this file, if you see, it is a simple open format for guiding coding agents using 60K open source projects. Think of agent.md as a readme for agents, a dedicated, predictable place to provide the context and instruction to help AI coding agents work on your project. Now, just imagine if I go ahead and create this agent.md file which gives basic information of the kind of projects that we may be developing, okay? Or the necessary initial context that may be required for the agent so that it gives us an accurate answer. It's just like Let's say that this is my deep agent, okay? And before I call this deep agent, along with the prompt, I want some more information to get loaded within the deep agents, right? For this, I can actually use something called as agents.md file, right? And this agent.md file is just like a context given to a deep agent. Now, I hope if you have used Claude Code in your projects, you usually create a file which is called as claude.md, right? This claude.md is also doing the same thing in the Claude Code runtime, giving the necessary initial context, right? So we will try to go ahead and create this agent.md file. And remember, the reason why I'm saying memory in deep agents, because this agent.md file needs to be saved in some memory, right? Over there, we will try to save it over there and we'll try to load it from there. Okay. Now here, let's read about this. What is memory in deep agents? Memory file provides persistent context that is always loaded in the system prompt. So this whatever things we are specifically writing in agent.md, it will be always loaded along with the system prompt. Use memory for project conventions, user preferences, and critical guidelines that should apply to every conversation. Okay, so I will also show you one example of creating this agent.md file. Okay, it will be amazing because we will try to see that, okay, this agent.md file can play a very important role, because if we have any kind of guidelines to be written for the any kind of projects that you are developing, we can basically mention it over there, so that along with the system prompt, it is always loaded whenever we go ahead and call a deep agent. Okay, so memory is always loaded into the system prompt. There is no progressive disclosure of memory. Why keep memory minimal? And always you should remember, only keep necessary information inside this specific agents.md file, because we don't want to load everything in the memory, because it will probably be no, it'll probably lead to more confusion to the deep agents model, right? So you need to probably make sure to have a small memory, fewer tokens, lower cost. If you have a huge memory, if you're putting more information in the agent.md file, the agent may also get confused. Okay. Now, how the memory is specifically used? Let's say the user goes ahead and asks a question. You create a CRUD API. Okay. So this is basically a user query. In the system prompt, obviously we will write instruction, that is base instruction, behavior, tone, rules. Memory files will also be loaded, and inside these memory files we may have what kind of the guidelines should be with respect to the code and all, right? So that will get loaded on top of it. It will be combined with the system prompt and it will be sent to the LLM. So here the deep agents will be able to get more amazing context in order to accurately answer this particular question. Okay, create a CRUD API. You can also get a text response. You can also get a coding response. But based on your requirements, what kind of response you want, right? You will be specifically providing in the system prompt, but more additional information you can more provide inside this agent.md file. Okay. So this is what exactly it is. One example, one very good example that I've shown over here. Let's say I'm creating one product for Krish AI, that is my company. I want to use the backend as fast API, database as PostgreSQL, cache as Redis, vector DB as Quadrant, Claude, AWS as Kubernetes. So this is the architecture that I have decided. Now, whenever I say create a CRUD API or create a fast API, create something, right? It is going to make sure that based on this AI architecture, it will try to give us this entire code. So here, if I go ahead and ask, build a RAG pipeline, the agent already knows your entire backend stack. And based on that, it will be able to create it, right? And here you can see how memory connects to backend. Memory file stores your backend architecture so that agent always uses the right components. Okay. So let me go ahead and show you one example. Okay. And for this also, I don't want to probably go ahead and manually create specifically manually create a agent.md file. So what I will do, I will also go ahead and use Claude Code. Okay. Obviously, I want to make my coding standards little bit fast. Okay. So here is my Claude. I think I will written a Claude code. Instead, I will go ahead to command prompt. I will just go ahead and write Claude. Okay. Now I will say, hey, I'm saying inside my deep agents demo. Okay. I'll say inside the deep agents demo, create a folder projects, and inside that create a skill not skill sorry create a agents.md file. Okay, I think it is agent or agent.md. Agents.md file. Okay, yeah, agent.md file. And this file should have some info that can be loaded in the deep agents whenever it is invoked. Okay, so I'm just saying that. And in this particular scenario, let's say inside this agent.md file, I may go ahead and say that, hey, please uh, see inside the agent dot create a folder inside the create inside that create agent.md file. This file should have some info that can be loaded whenever it is info. It can have some architecture info related to deep agents. Okay, so I'm just putting some kind of information over here. Right now, what this will do is that this will go ahead inside this particular folder. It will go ahead and create a folder which is called as projects, and then it is basically going to probably go ahead and give you the entire information. It will go ahead and create that agent.md file, right? So this is again, you can add any amount of information, but let's say that brief architecture information I really want to add in my project, so that I go ahead and when I'm creating more information, automatically, my deep agents will be first of all, and again, I have to read all those information, combine it with my prompt and all, right? So here you can see Claude code, all the information is basically there, architecture overview, everything is there. I'll just go ahead and click on yes. Okay, and here you can see inside my project folder, my agent.md file is basically created. Okay, so here you can see that. Okay, and then you can see my entire agent.md file. Open preview. Okay, so this is my agent.md file. Now, what I really want is that whenever I try to answer any question, I try to ask any questions about deep agents, this should also get loaded. Okay, this should also get loaded. Okay, now load this agent.md file in the deep agent and test it. So now I don't have to do this. Okay, so let's say that this is my agent.md file that has got created. Now I'll go back to my context engineering file. And the first thing that I'm actually going to do over here is that I will say, I will write some information so that you should be able to read it. Since I have already defined that agent.md file over here, I will say instead of hard coding a long string into the system prompt, we can keep the agent operating context in a separate agent.md file. And for this, no, I will also make one change. Instead of, I will just make it capital letters. Okay. Good practice is this, but it's okay. I think unless and until you're giving the same path, it should not be a problem. Okay. Then this is a context engineering, the durable, who you are, how you behave, context live in a variable edit, not buried in the code. Okay, now this is done. Okay, now what I will do, I will first of all read this agent.md file because I need to combine this with my prompt. Okay, so for that, I will write from pathlib import path, okay, and I will read this agent.md file. Okay, just to make sure that I go ahead and add this in along with my system prompt. So here I'm going to write agent_md. I will go ahead and write path, and you know my folder, right? My folder is nothing but projects slash agent.md. Okay, and we will go ahead and read the text, read_text. And here, since this is in the markdown format, we will be using an encoding which will be like UTF-8. Okay, and now if I go ahead and see my agents.md file, it should be able to give me the entire information. See, deep agent context, the file is loaded into a deep agent context via when the agent, its own architecture, the project convention, all this information is there. Okay, now the next thing that I really want to do is that I want to combine this entire system prompt along with this particular whatever information that I have in the agents, this agent.md, which will be like an initial context that will be specifically given to the deep agents out there. Okay. So now what I will be doing is that you'll be clearly seeing that, first of all, I need to first of all go ahead and create a memory, right? Because I need to load this entire MD file into the memory. So for that, I will write from langgraph dot checkpoint dot memory saver, and we will go ahead and just initialize check pointer is equal to memory saver. Okay. Now, whenever I need to load this agent.md also, I will be requiring some memory access, right? Now, what all memory access we can basically use? Okay, how the memory access part will be taken care of. So for that, I have this backends functionality. So if you go in deep agents, since deep agents has access to your system, your it has read and write operations, you can basically do a kind of read and writes and all, and it can also access memories from your system. It can whenever you are creating any kind of deep agents internally, there'll be a langgraph memory that will be there. Okay, so for that we will be using something called as backends. Okay, and this backends is nothing but it is where the agent files memory lives. Okay, a backend is the storage layer behind the agent file tools, and its memory is equal to the same agent code, different durability. Okay, so there are three types of backend that are available. One is the state backend, file system backend, and store backend. Okay, we will be discussing one by one with respect to all this particular backend. Okay, now first of all, what I will do is that I will go ahead and call this. Okay, so I'm creating an agent, create deep agent. I'm using OpenAI 5.0. And when we say check pointer is equal to memory saver, right? Here, no backend is basically used, no memory is used, no files is used. So these all are parameters that can be added over here. Okay. This check pointer will basically be storing within the same session, within this particular, in the internal memory itself, right? So once I go ahead and just invoke this, okay, invoke this, you should be able to get, see, I'm basically saying that, let's say this is my deep agents over here, okay, and I'm invoking agent.invoke, role is equal to user, content is equal to, here is a project guide, and I'm giving my entire agent underscore MD over here. So this is one way how you can go ahead and add the entire information that is available directly into your prompt. This is one way. Okay. So here you can see, here is a project guide, agent MD. Now, who are you, what you should follow, everything you should know, right? I'm a deep agent from complex multi-step stars. I should follow the convention in your agent MD as a source of truth. Plan first for all multi-step works using right to-dos. Offload bulky intermediate works. All these things has been provided. Now, whenever I ask any question with respect to invocation, right? With respect to invocation, who are you, what you should follow, all the information is basically coming over here, right? But you still feel that if you try to directly give this information into the prompt, your prompt may become much more bigger, right? So it is basically a good way that we try to load this agent underscore MD directly into the memory, because here we are not, here we are using just internal memory, but there are some different kind of memories that are available. One of the memory is something called as state backend. Okay. State backend is nothing but it lives in Langgraph state. Okay, one thread with a check pointer. So by default, if you see over here, check pointer is equal to memory saver. This is basically using the state backend. Okay, state backend. That basically means within that particular Langgraph session, Langgraph state, the information will be basically stored. When the agent will be closed, then automatically all the information will be gone. There is another backend which is called as file system backend, and this is basically storing all this context in the root directory, basically in the hard disk. Okay, everything, it's just files. Okay, then you can read project files directly from the hard disk that already exist over there. Then there is also one more option which is called a store backend, and this is nothing but this, you are storing it in some kind of base store or a vector store. Okay, you'll be able to access them. These are like long-term user memory that persists between separate sessions. Now, right now, I have just used by default state backend, but I will show you uh, one more way of how to call this particular how to call this entire agents.md file and load it along with the state backend along with the prompt itself. Okay. Now what I will do here, you can see default backend with no backend specified files slash memory leave in this. Okay. So first of all, what I will do, I will go ahead and create my agent. So agent is nothing but create deep agent. Now this is my another way of calling it. So the model that I'm actually going to use is nothing but OpenAI GPT 5.4. Okay, 5.4. And then here I'm going to use memory. So there is a parameter which is basically called as memory. Okay. Now inside the deep agent, you can directly pass the memory. Okay. So the memory is obviously present where? Inside my projects folder. So first of all, you need to go ahead and find the project folder agent.md file, right? So this is basically my folder and I will be using a checkpointer, which will be my memory saver, right? Now, what is basically happening in the code? You really need to understand it very clearly. Okay. A lot of suggestions are basically coming, but it's okay. Okay. So here what we are doing is that we are saying that when we are directly creating the deep agents, the memory from which it should probably go ahead and use is from projects agent.md, right? And please try to use the default backend. The default backend where it is going to store is state backend. That basically means when this deep agent will be working, it will try to store it within its state, like the same LangGraph state. Now this is there, right? This is there over here. Now, the next thing is that I will go ahead and create this agent. Now, the next thing is that how do I go ahead and invoke this particular agent? Now, in order to invoke this agent, I will go ahead and write something like this. Result agent.invoke. This is my message. What is in your memory? I'm just asking because just to understand like whether the agent remembers its memory. But along with this, there will be one more parameter which is called as files. And this file will be the path of the agent.md file. Okay. So we are seeding in that instead file, right? And this agent_md has all the information when we are using this information over here. See, when we go ahead and call this particular function, which is called as create file data. And for that also, we need to go ahead and import something. Okay. What exactly this is? See, so if I go ahead and execute it, it is basically creating a file itself, right? Create agent.md file. And this is the file information that I have, right? So now let's go ahead and execute this. So here I have agent.invoke. I have given the files path, everything. Now let's see whether this will be the answer, whether the deep agent will be able to give the answer with respect to what's there in the memory. Okay. So obviously it should give all the information that should be there in the agent.md file. Okay. Now here you can see I don't have any personal hidden memory in the human sense, but I do have some persistent project instruction loaded. What's in my memory? I'm operating as a deep agent. I'm supposed to plan first for multitask using a to-do tool, use sub-agents, right? Who am I? Everything information is basically now given. And this is basically getting read from here, right? And that's the most amazing part about this context engineering. You are able to see this specific information, right? Now, what we will do is that we will try to go ahead and use some kind of memory in the backend, right? We have already seen that if you use the state backend, that basically means we are basically saving it in the LangGraph state, right? What if I show you some more techniques, right? Which basically stores in some of the information, some more where, it basically stores it in some different path, right? Like store backend and all, right? So for this, I will copy one more code and I'll show it in front of you. Okay, just need to understand the code, guys. Anyhow, all this code are very easy. Okay, this time I'm storing it in some store backend. Okay, now this store backend here, you'll be able to see that from deep agents, I'm going to basically import, create deep agents. I'm importing store backend. Now I will go ahead and create a store. The store is just like a vector store. It'll be like an in-memory store itself. Okay, it's a seed durable memory into the store once, name plus key identity the file. Inside this particular store, I will go ahead and create a key called as memories, and inside that I will put up all the information like what is the agent.md file, along with that whatever content that I have over there, right? So here you can see clearly that I have saved all this specific information. And then we go ahead and create a deep agent. And in the backend, when we write backend is equal to, we basically assign it to that store backend, right? And here you can see store is equal to store. We have given namespace lambda RT is just like a lambda function to probably access this particular key, right? And memories I have inside my projects, this projects slash agents.md file. So guys, now let's finally run this. And remember, this is like having your own store. You're putting those kind of information which you initially load, and let's try to run it. Okay. So now if you go ahead and probably run it, here you can see memory none loaded. Who am I? Deep agent accessed via API. I am with research coding, file edits, analyze, multi-steps. All the information is basically coming, right? And here you can see what's in your memory. It is basically able to read it directly over there. And you can also see the entire detailed results with respect to all the communication that is basically happening, right? So this was an example of specifically using, see, one example we saw with state backend, one example we saw with basically store backend. Okay. There are still multiple different examples which you can go ahead and still explore. So guys, now we are going to see one more type of backend, which is basically called as file system backend. And here, the main thing will be that we will be reading the project file slash agent.md that already exists in a disk directly from the disk itself. And the root directory will be the disk itself, right? Already we have seen about state backend and store backend. Store backend basically stores in some kind of base store, state backend in LangGraph state, file system backend directly from the hard disk, right? So now I will go ahead and paste a code over here. So this is the code. Here you can see file system backend read files slash memory straight from the disk. Why? The agent files and memory maps to real files on disk under root directory. Nothing to seed. If agents.md exists on the file, memory just loads it. Okay. So for this, we will be importing from deepagents.backend.file system, import file system backend. Root directory, I will be giving it over here. See, inside this backend, there will be file system backend, root directory will be projects. And inside the projects, I have this agent.md file. And checkpointer will be as memory saver. So whenever things are basically getting saved, it will probably go ahead and directly pick it from the disk itself. Then you have this. I've asked the same question. What is in your memory? Who are you? So if I go ahead and execute it, I think I should be able to get an output because it is loading the context directly from the agent.md. So here you can say I'm a deep agent and AI assistant designed for multi-step task. Okay. Then you have this fs.agent.invoke. I'm just asking another question. What is LLM gateway? And I think it will first of all load this specific context and then it will try to answer it. Okay. So this is just an example over here. The main part is that we have discussed about input context in terms of system prompt. We have also understood with respect to memory. Now, when we are trying to load it from the memory, we have seen three different backends, which is really core important, right? One was the state backend, which is basically getting saved in the LangGraph state. Because see, if you are loading anything into the memory, we need to probably save it somewhere, right? Memory means whose memory, what memory, which memory. So one memory is directly from the state backend, one is from the store backend, one is from the file system backend, which is supported by LLMs. Now, which is supported by deep agents. Now, in my next section, what we are going to do is that we are going to learn about one more input context that is called as skills. Okay. The skills we will be discussing, like what exactly skills are, why skills are very useful, in what kind of use cases it can be very useful. Okay. So yeah, this was it. I'll see you all in the next section. Hello guys. So we are going to continue the discussion with respect to deep agents. In this particular section, we are going to discuss about skills and deep agents. We'll go ahead and discuss about it step by step. We'll also try to understand how we can go ahead and implement skills. Okay. So three main important things are there in this topic. First of all, we'll understand what are skills, how skills will be used with respect to practical implementation, and how it is different from memory, right? The memory part which we initially implemented. So first thing, let's go ahead with the definition over here. Skills and deep agents are like on-demand expertise with progressive disclosure. Skills are specialized capability modules that the agent loads only when they are relevant to the user request. So this is not getting loaded all the time. So whenever the user requests for some type of task, right? At that point of time, skills are a kind of capability or module that will be loaded by the agent. Okay. So here you can see with respect to memory, it is always loaded in the system prompt, right? Let's say that let's say there is a question, tell the agent about your world, right? Project rules, architecture, preferences. So this scenario, all the time, the agent.md file that we had actually created, right? This will get loaded in the initial stage. Everything will get loaded, right? But let's say if I go ahead and ask a question to the user, teach the agent how to do some specific jobs. Or if I go ahead and ask a question, teach the agent uh, how to probably go ahead and write a Python code, right? So what we can do for that Python code, right? We can create a Python expert as a skill, okay? Because it is a kind of a specialized capability. And whenever we ask this kind of question, this skill can be loaded in the context of the deep agent, and then the deep agent will be able to give you the output, right? Now, inside this particular skill, we will be having some rules with respect to this particular skill, what this Python expert can actually do, each and everything, right? Some rules and instructions we can specifically provide. Similarly, in a project, let's say you're asking any questions related to AWS, right? So what I can do is that I can go ahead and create a skill named AWS expert, which will have some specialized capability to answer AWS types of questions. Similarly, LangGraph expert, Kubernetes expert, and all. So we will go ahead and create this. I will show you how to go ahead and create it. Key idea is that don't load everything all the time. Load the right skill at the right time for the right task. Okay. Let's say if the user is requesting build a RAG application. So initially, you know that system prompt and the memory agent.md file will get loaded. Okay. It will first of all understand the task and identify the requirements. On top of it, based on the query that is given, it will go ahead and search for that particular skill and try to load it, right? Select and load only relevant skills based on the question. It will not load all the skills at any point of time. Okay. Then here you can see how the skill loading is basically done. There will be a load skill instruction, example, best practices and tools. And finally, by taking this specific context, it will be able to give you the output, right? And then after the execution is done, it will unload. The skills are released after the task. So this way it is keeping the context clean. Now you need to understand the differences between memory versus skill. Memory is always injected into the system prompt, loaded only when relevant. Global rules, preferences, architectures, and conventions, detailed workflows, domain knowledge, step by step guidance is nothing but skill. Small, high level information. This is large, deep, situational. Coding standards, backend architecture, security. These all are the examples which we can specifically load in the memory. But what I feel, memory is like a superset. Skills is just one part of the information, like some specific capability, right? Here you can see example Kubernetes deployment, LangGraph workflows, AWS setup and all. No progressive disclosure. That basically means once this memory is loaded, it will not get released. Here, there will be a disclosure. Only it will be loaded when it is required. Okay. Let's see some of the scenario examples. Create a graph RAG system, user request, skills loaded, Python, LangGraph, Neo4j, ChromaDB. User request, let's say user is saying that deploy it in AWS, the skills will be loaded like AWS, Docker, Kubernetes, so that these all skills capabilities will be there in order to execute that particular task, right? And one very important information is that what will be there inside a skill. So let's say there will be a skill folder, there will be another folder. Inside that, there will be an MD file, instruction.md file. There'll be some examples file. There'll be some best practices file, right? I will try to create this similarly. You'll be able to understand it, okay? Uh, how skills fit into the deep agent architecture. First, user will and understand this is a kind of an agentic workflow, right? Agentic loop. It is just like an agentic loop. You can see completely agentic loop. So first a user asks a question, main agent planner will analyze the request and plan the step. Then a skill selection will happen. Then the execution layer. Then again the result will be displayed. Then again this can keep on going ahead, and different skills can be used. Okay. Now I've spoken many things. Obviously, you are super excited for the session, the practical implementations. So now what I will do, first of all, I will just go ahead and create my another tab. Let's say here I will be talking about skills, And what is this part of? In memory context, right? Memory context. Perfect, right? Now you have heard about the definition. It is some kind of capabilities which can give more information to the agent when it is executing. Now let's try something. So here again, I will close this. I will just open my command prompt. I will go ahead and write Claude. Okay. Now the reason why I'm writing Claude over here, because I want to create the skill with the help of a Claude. Okay. So basic things I will do inside this deep agent demo. I'll create a folder which is called as let's say skills. Okay. If you probably see over here, what is the folder structure that we specifically have? Let's say skill is there. And, I will try to, you can also give a screenshot of an image, right? In order to probably go ahead and create skills. Okay. Um, so let me do one thing inside the skills. I'll say, please create skills like Python skill, skill, LangGraph skill. Okay. And you can see over here other skills that I have. AWS skill. Inside the skill folder, these skills should have a, let's say it should have a skill.md file, along with that instruction.md files. Okay. And it should also have examples.md file and instructions.md files. Okay. All these files will be used as context to the deep agent when the query is being asked by users. Okay. So that the skills will be internally used. Also create one more skill to, let's say I want to probably go ahead and create this particular skill to write a report. Okay. I'll just say to write a report whenever the deep agent answers. Now I know I'm writing so many information, but here you'll be able to get an idea, right? Now what I'm actually planning is that I will create a set of skills inside this particular folder. And whenever I ask any question to my deep agent internally should be able to load this specific skills. Okay. So here you can see that context engineering is providing the right information tools in the right format, right? So here you will be able to see yes. So once I probably start creating this, right, automatically you will be able to see all the information with respect to this particular skills that will get created. Okay. It'll take some time. I will just go ahead and say yes. Let's see. Yeah, it'll take some amount of time. So here my skills will get created inside the skills folder. This skill should inside the skills folder. I have actually written. Again, it'll take some amount of time. Let's wait till it basically creates this specific skill. So now you can see skills Python skill.md file. I'll just say yes. So here is my first Python folder that has got created, and automatically it will also create some other things, right? And this is just like a context that will be given over there. See, instruction.md file, I have this. So here inside my Python, you also have instruction.md, skill.md, right? And then the other MD files that I have actually provided. Okay. And we can load this inside the deep agents. You will be seeing that how we will be specifically loading it. Okay. It'll be quite amazing. And there also we can specifically use backend. And for this, we'll be using another kind of backend. Okay. And that backend will be something called as code interpreter middleware. Okay. I will show you. I'll show you in just in some time. You can use state backend. You can use some other kind of middlewares also inside this. So let's see whether my another, see, this is Python. Inside my Python, I have example.md file. See, follow the structure. Okay, this, let me just press enter. So inside my example.md, some examples with respect to the Python code is basically given, right? Instruction is that follow this workflow for every Python related query, identify what the user wants, each and everything. Okay, what the user wants, new code, bug fix, refactor, explanation or review, design before coding, right? All this specific information, and this format is already there. You can use Cloud Code. I don't had to create it manually, but if you go ahead and just preview this, you should be able to see this. Okay, so it is still creating. If you go ahead and just preview it, right, this is how the md file is basically created, right? So for every folder I will be having this 4 different files, right? AWS, and here also you can see that in AWS also things are basically getting created. I'll press enter, instruction.md file. So any question related to LangGraph will be using this specific skill. Any question related to Python will be using this specific skill. Yes, we can also integrate more tools to our deep agent, but initially just to load that specific skills over here, we can directly use it. Okay. And I'll show you, it will be shown like how you're specifically using this particular skills and all. Okay, so all the skills I basically get created. I've created AWS, I've created LangGraph, I've created Python, you know, all the specific skill sets I'm actually creating. And here our main aim is basically to teach you like how deep agents actually work, right? That is the main core functionality area over here, and we are trying to learn that thing. Okay, so here the report writer is also been done. I'll just press enter. Okay, so report writer is done. When to trigger, write a report after answering any questions and all, right? I will show you how to probably trigger it. Okay, now let me go back over here. Okay, let me complete this first of all. Quickly we are creating, right? So I did not do anything. I'm just using Cloud Code to do it. It is important and it is efficient that you try to go ahead and use the same technique. Okay, and then finally I will. So let's see, reporter, writer, and here are all the files. Perfect. Great, right? Now, let's do one thing. Let's close this till then. Now I'll show you how we can use the specific skills. Okay. Now, initially, we will go ahead and start with importing some of the libraries. So here you can see that I've imported from URL lib, URL open, and along with this, we are also importing state backend, create file data. And there is one very important library that we are going to use, which is called as Langchain quick.js. Okay. So I'll copy this and I will quickly delete it. Let's close this. Okay, and then I'll open control B. I'll update my requirement.txt. Okay, and we will go ahead and use this or install this. I'll go to my command prompt. I'll write uv add -r requirement.txt. Okay, so quickly Langchain quick.js will get imported, okay, or loaded, and we will try to install all these things. Then after doing this, we will go back again over here. So this has got done, completed, and let me close this. Now all the important libraries has been imported. Here we are going to use a checkpointer and state backend, which is basically the Langchain backend. Now you know that how you can go ahead and read all the skills files, right? So first of all, I need to probably go ahead and read all the specific skill files. Now, how do I go ahead and read all the skill files? So I will write from pathlib import path, which I have already shown you. Okay. And I will just go ahead and say, let's say I want to read one content. Okay. So I can basically go ahead and give the path. Let's say skills langgraph skills.md file read underscore test encoding UTF-8, right? Then here, if I want to read any number of files, so with respect to this particular content, I should be able to get it. So once I execute this, okay, let's say once I execute this, so I'm getting a no module langchain dot quick.js. Why that is, okay, I need to probably restart it. Let's see. I will restart it. Okay. I will restart it. The reason is that because I've installed the libraries now. Okay. And then we will try to execute it. Let's see. Okay. So you can basically go ahead and read any number of skills. That is up to you. Okay. And I will also be showing you how we can actually go ahead and read it. Okay. Oh, it is taking some amount of time. No worries. Let's see. Let's see. Let's see. So once the library has been installed, let's go ahead and execute this. Okay. Uh, okay. I'll restart the kernel. Initially, you'll require to restart the kernel. Okay. Now let's execute it. Name skill content is not defined. Why it is not defined? Okay, I have to execute this beforehand. Just a second. Okay, the skill content. We need to have this particular skill content. Okay, it is skills content. Okay, I think there is a small spelling mistake. No worries. Let's execute it. So guys, now you have seen that how we can read a specific skill. So now see, our main aim is that we try to read all the specific skills. So for that, you'll be seeing that I've created skills directory called as LangGraph, Python, AWS, report writer. And we are basically, calling all these particular folders, and internally we are reading all the skill.md file. Okay. So once we go ahead and execute this, you will be able to see that my skills file will look something like this. So I have the Langgraph skill.md, Python skill.md, AWS skill.md. Now, why I am specifically reading this file? Because when I call the deep agent, I should be able to give the reference of all this MD's file within my deep agent. Okay. So the next step will be that I will go ahead and create my deep agent. So here you can see agent is equal to create deep agent. The model that I'm using is OpenAI GPT 5.4. The backend that you see that we are using state backend. The skills folder path we have given /skills, which is nothing but within this specific root location. And check pointer, I've actually used a memory check pointer. Now, in the agent.invoke, I am asking questions. What skills do you have available and when would you use each? Okay. And along with that, like how I gave for the memory also, right? Some references. So here I'm actually giving all the skill files. And finally, you can see that we will configure this with one thread and we are printing the specific message, right? Now, what it will do is that since it has reference to all the skill files, it will be able to tell you what all skill it basically has and what skill is used for what purpose. Okay. So now here you can see that available skills are AWS used for AWS services and architecture, EC2, S3, Lambda, all this information is basically there, right? Now the next step will be that I'll go ahead and ask any questions, right, by using this agent.invoke. And I will just ask in such a way that I'll basically say, okay, please tell me, like, let's take this example to trigger the skill because I want to trigger some skill over here. Okay. So this is my result. You will be able to see my detailed result. I will go ahead and trigger it. Now I will ask, how do I build a lang graph with conditional routing and memory? Show a minimal example. And I'm giving all the skill files and I'm keeping a thread ID, something like this. And I'll print it by using uh, m.prettyprint. Okay. All the messages I'll try to print it. Now see, one amazing thing is that when I'm asking this question, right, automatically deep agent is going to make sure that to see whether there is any skill sets that is available, right? And it will try to even make a tool call. Let's see whether it will do or not. Okay. So I'm printing it over here. This is my another thread that we have created. And now I think I should be able to see it. So first the human message will basically come. I'm invoking the same message. I'm giving the same skill files, you know, internally, it is just going to load any specific skill set that it wants. So I've given all the skill. So here you can see, how do I build a lang graph with conditional routing with memory? Show a minimal example. Here it shows that it has loaded. It is loading this lang graph skill.md file. Isn't this just amazing? Automatically, it was able to understand, right? And inside this skill.md, it was able to find out from this name, description, metadata, all this information it is able to match and it is able to give me, right? Then it is going to read the specific file name langgraph. See, all this information is basically coming up. And finally, it gets the context and it is generating a message. Use state graph plus router, this and all are there, right? Isn't this just beautiful, right? And you can see update file, langgraph, conditional routing, report.md, right? All this basic information is basically available. And that's the beautiful part about this, because you're able to get this entire information out here. So here you can clearly see that how it is able to call a specific agent. Now, similarly, what I will do, I will copy this entirely. Okay. And let me go ahead and ask some any questions related to AWS. Okay. How do uh, I'll just go ahead and say, how do I set up an EC2 instance? Okay. It's EC2 instance in AWS. Okay, so now if I ask this question, let me change this thread so that my previous conversation should not be, it is just like a new chat that we are trying to do over here. So now if I go ahead and ask this specific question, obviously it is that we need, it will definitely go ahead and call our AWS skill. So this skill it is going to basically call, right? Like here I've just read skill.md. You can also read instruction.md, examples.md, whatever things you really want. Okay. So let's go ahead and print this. And here now internally, you'll be able to see that somewhere the skill will be getting called, and you will also be able to read it clearly. See, there is a tool call that is specifically happening in the previous request, right? So here, how do I set up an EC2 instance? So argument event over here, AWS skill.md is basically there. Read file is there. Now to set up an instance, sign into the AWS console, all the information is basically over here, right? And again, whenever you are asking a specific question, only some specific skill set is skills are basically getting loaded, right? Let's say that if I go ahead and again ask related to Python, okay, write a code in Python related to oops. Let's say I'll go ahead and write something like this. Give an example of oops in Python, right? So once I go ahead and basically execute this, let me make another thread altogether, and automatically you should be able to see that particular output. Give an example of oops in Python. So I'm directly getting an AI message over here, right? So that basically means it was not able to call this particular skill, right? The Python skill. Okay. I will just go ahead and change this question. Write me Python code to do binary search. Let's see. I don't know whether it will be required or not, but at least it should be able to give you the output answer, right? So let's see this with respect to all the messages that it is going to basically do. Internally, it will definitely use it. Am I giving the skill files? Yes, I'm giving it over here. And now you should be able to see the output. Let's see. Let's test it out. So here now it is basically called. I just made my question a little bit better. Then it is able to call this particular file. It's just like a tool message. It is just like a tool call. It is being done, right? And here you have the output. So this was the most amazing feature about skill, and I hope I was able to clearly make you understand why to specifically use skill. It is just like an expertise that you are providing as a context to your deep agents to use it whenever it actually requires. And in this section, we discussed about skills. Hello guys, so we are going to continue the discussion of deep agents, and in this specific section, we are going to discuss about a new topic which is basically called as sub agents. Now, first of all, we will first of all understand what exactly sub-agent is, and then later on, we'll also go ahead and see the practical implementation and how we can actually create sub-agents along with your main agent to delegate any kind of task. So here you can see a deep agent can create a sub-agent to delegate work. You can specify custom sub-agents in the sub-agents parameter. Sub-agents are useful for context quarantine, keeps the main agent context clean, and providing specialized instruction. Now, just to show you or explain you more about this, initially we will try to cover up about synchronous agent. In the synchronous agent, we will be seeing that the supervisor will block until the sub agent finishes. So let's say that there is a main agent over here. Whenever a task specifically comes, it is going to delegate work to the sub agent. Here you can see there are different sub agents like research, code, general. And finally, you'll be able to see once it is basically completed, all the tasks will be combined and sent back to the main agent. When we talk about synchronous sub-agents, one very important thing is that whenever the main agent is delegating the task, the main agent will be blocked. Okay, so this is basically the supervisor, it will be blocked unless and until the sub-agent will be completing its task. Okay, and this is what basically happens in the synchronous sub-agent. As we go ahead in the next section, we'll also be seeing something called as async sub-agent. So at that point of time, your main agent will not be blocked. Okay, so that we'll be seeing in another example. Now let me go ahead and let me probably talk more about this, what all things a sub-agent can basically do, each and everything, why specifically use sub-agent, what is the differences between sub-agent and main agent. So first thing first, over here, you will be able to see the clear definition. Sub-agents are specialized AI agents that the main agent delegates tasks to. Each sub-agent has its own context, tools, memory, and instruction to perform a focused job and return result. So one very important thing that you'll be able to see is that every sub-agent that the task it is probably doing, it will have its own context, tool, memory, and instruction. Okay. Why you use sub-agents? It is very simple. It will actually help you to break complex tasks into manageable part. So let's say that you have an agentic workflow, which is basically solving a very complex task. At that point of time, you can divide those tasks, so complex tasks into subparts, and you can give those subparts to the sub-agents to solve. Run tasks in parallel for speed, isolate context to reduce noise and token usage, use the right tools and skills for each jobs, improve reliability and maintainability. Just by seeing all these things, I think now you should be very much familiar with all these topics that I'm actually talking about. Okay. Now, what is the differences between sub-agent and main agent? Main agent is that it understands the overall goal, plans and decompose tasks, delegates to the sub-agents, aggregate all the results and returns the final answer. Whereas in the case of sub-agent, it is focused on a specific task. This is really, really important. It has its own context, own tools and skills. It can also use other tools and skills that are available, and it returns a structured result. Okay. Key takeaways are sub-agents turn one general agent into a team of specialists. Okay, delegate the right task to the right expert. And along with that, you'll be able to see how sub-agent works. Whenever a user request come, let's say we are asking build a research report on agentic AI. First, the main agent understands the goal, creates a plan, decides which sub-agents are needed, and it will delegate the task to the sub-agent, right? So one of the sub-agent may be a research agent, a writing agent, a data agent, critic agent, and then you combine all those things. They execute everything in parallel. One more very important thing is that you'll be able to see they'll also be able to communicate with each other. And finally, the results is basically returned. Okay. When to use sub-agent? I hope everybody has now understood it. Okay. Now, let's do one thing. Let's go ahead and probably talk more about sub-agents in terms of how we can implement in the practical example. Okay. So first thing first, we will go ahead and import all our environment variables. So here we are going to use OpenAI API key. Then you have something like Grok API key, Tavli API key, and this is common what we are specifically doing. Okay. Now let's do one thing very simply. Okay. I hope in the initial stages, we will first of all create a specific tool which will be a kind of an internet search. Okay, it will do an internet search. So first I'm importing OS. From typing I'm importing literal. From deep agents, import create deep agents. I'm using a Tavli client, and I've already imported have the Tavli API key in my .env file. Okay, now by all this information, what I'm actually going to do, I will be creating a internet search tool. Okay, and this specific tool will take some parameters, right? And these parameters will be like query, max results, how many results, topic, like which all topic it should probably search, general news, finance, right? And by default, it will be general. Include raw content, boolean is equal to false. Okay, so we are giving these parameters, and initially we have discussed about this, right? And here I will give some statement so that you will be able to understand, like it does a run web search. Okay, so we are putting some kind of doc string over here. Now, inside this particular function, what we'll do, we will be using this Tavli client, and we will be returning a result based on this particular query, max results, include raw competence and topic. Okay. So this is what is the tool work that it is doing. Let's say internet search, right? Now let's say this internet search instead of integrating a tool, right, what I will do, I will go ahead and create a sub agent. So let's say this will be my research sub agent, okay, is equal to, and with respect to any kind of agents, we really need to give all this specific information, like what is the name of the sub agent, what is the description of the sub agent, right? What is the description? You used to research more in-depth question, system prompt. You're a great researcher. You can write any kind of system prompt. And what tool it is specifically using? It is using this internet search tool. And you can add any number of tools over here. And here you have model. Okay, model name, whatever models you are using. One very important thing is that this is optional. It can override default to the main agent model. So if this model is not working, we can basically see that whatever the main agent, whichever model it is using, it will probably go ahead and use this. Now this is my sub agent. Now I will go ahead and create one more key, which is called as sub agents, and this will basically be my first sub agent that I'm going to use. Okay. Now let's go ahead and integrate our main agent with this sub agent so that whenever a query is gone to the main agent, right, we go ahead and delegate any kind of task to this specific sub agent. So here I will write agent is equal to create deep agent. And here I'm just going to use one model. Let's say my model that I'm actually going to use is OpenAI. You can use any other model that you want. Okay, no worries. If you want to use even the Grok model, you can go ahead and use it. 5.4. Okay, so I'm using 5.4 model, and I'm going to basically go ahead and it should be a comma. Okay, and then here I'm going to basically use the parameter that is available over here in the create agent, which is called as sub agents. Along with that, I will also make sure to keep verbose is equal to true. Okay, so let me just go ahead and write over here verbose is equal to true, just to see more information out here. Okay, perfect. Now this is my agent. I will just go ahead and display my agent over here. On line number 9, let's see what is the issue. Run a web search. Okay. So I think that the issue is over here. Okay, perfect. Now, once this gets executed, again, there is an verbose. Okay, verbose parameter is only not there. Let's see. Verbose, what it is, verbose. Okay, unexpected argument. I think it is not there. Fine. Now we'll go ahead and execute it. We'll see the agent, how the agent looks like. So here is my agent. This agentic loop will always be there. And then along with that, we'll also have a sub agent. Okay. Now it's time that we will go ahead and invoke this specific agent. Now, in order to invoke it, it is very simple. I'll be using agent.invoke. Here I'm using role is equal to user. Content will be how do I build LangGraph with conditional routing. So show a minimal example. Instead of this, I'll go ahead and write research about LLM gateways and provide me a detailed summary. Okay. Now, when I'm doing this, obviously, when this task will be given to the main agent is going to delegate the task, since we already have this amazing sub agent, which is called as research sub agent, and it will probably do an internet search and try to find out all the details. Okay. Now, let's go ahead and execute it. And automatically, I think you should be able to see that the task will be delegated and you will be able to get all the response. Okay. So let's see that so that quickly we will be able to see. Okay. Yeah, it is going to take some amount of time because it is also going to do some kind of internet search within them and probably get the result and response. Okay. But here you can quickly see that how did we integrate a sub agents. This create deep agents has a lot of parameters. It is having memory, it is having skills, it is having sub agents, all those things. And I will also show you that how you can basically go ahead and use skills inside this also. Okay. As you know that we have already created multiple skills, we will also try to use those skills. Okay. And after this, we will also see that how we can come up with a structured output. Okay. So here I will go ahead and write structured output with subagents. Okay. Subagents. So let's see this. It'll take some amount of time, and let's wait till the output basically displays. So finally, here you can basically see that we have got the response. So human message was research about LLM gateways, provide me a detailed summary. And here you can see that it has started making a to-do list, right? Research LLM gateways, definition, capabilities, vendors, all this information is basically there. And you can see that within this right to-dos, that is a tool call it is specifically made. And internally, you'll be able to see that more information is being explored, getting information about LLMs, right? It is updating the to-do list, right? So all these things are actually happening and you are finally getting a specific response, okay? Which sees a response over here, right? So this was one of the example of how to basically go ahead and create a sub agent and assign that or integrate with the main agent so that you will be able to get a quick response. Now, what we are going to do is that one more example that we are probably going to see that how we can generate a structured output, okay, with sub agents. Okay, let's say that I want a structured output directly. I want to probably get a structured output with respect to any kind of response I get from the LLMs, and that structured output should definitely be coming uh, from my the sub agents that we are specifically doing. Okay, now and here you could see, right, tool message, research, LLM gateways, all this information is basically coming from uh, the sub agents output, right, which is being able to work. Now what I will do, I will go ahead and first of all import from Pydantic. Since I want a structured output, you definitely should know that we need to go ahead and import base models along with that field. Okay, if you know about Langchain and Langgraph, this is definitely there. Okay, then I'm going to go ahead and write from deep agents, import create deep agent. Okay, and then I'm going to create a class which will be like a research findings. Okay, because right now I'm not getting all the information in kind of some structured format, right? It is just a text detailed summary, all the things I'm getting. But just by using this, I will be able to get a specific structured output. Okay, so after creating this specific class, I will just go ahead and write this three fields. I'll create this three fields. One is summary, which will be of a type string, and this is like field with description, summary of findings. Confidence float, like confidence score from 0 to 1. Okay, sources, list of all the URLs that we are specifically going to use. Okay, then after this we are going to create our research sub agent. Now see this. Okay, this will be amazing, research sub agent. And within this research sub agent, there is again a parameter which is called as response format. Okay, we are going to assign this response format to the research finding that we have over here. It should be research findings that we have over here, or I can also make this as findings since we are going to get multiple URLs. Okay, so this is my research sub agent. Okay, now the next thing what I will do, I will just go ahead and create my sub agent like this. Agent create sub agent and model is equal to this model we are using, and sub agent is this. Now see this output. Okay, I'm writing result await agent.invoke. Okay, and I'm using role is equal to user research recent advances in quantum computing. Okay, so I will just go ahead and execute it. Now in this particular scenario, you will be able to see that when the tool call will be made to a sub agent, the sub agent will probably do the internet search and get you the output in this specific format. Like it will be having summaries, it will be having confidence, it will be having sources, and based on that specific information, we will be able to get it out. Okay, so just wait till this gets executed. See, these are like a deep agents. It is going to take some amount of time. Again, it also depends on the API keys, your internet speed, and many more, right? So once this gets executed, we will just go ahead and display our results. And when I display our results, right, you'll be able to see first, I will be able to have a human message, then AI message. In the AI message, there'll be a tool message, which will be probably this sub agent will be giving us the output in some format, and that format will basically be following in this key value pairs. Okay, and once it is done, that point of time we'll be able to understand that okay, fine, you can also create a sub agent and get a structured output out of it. Okay, so let's wait till this gets executed. So guys, here you can see that now it has got executed successfully. Now what I will do is that I will just try to display all the results and the messages that we have. Okay, by using the same thing. So here you can see human message, research recent advances in quantum computing, and here I have my AI message. You can see it is basically making a sub agent call. The tool message that is now it has summary. Okay, and further if you see that we will be having a confidence score and along with that sources. Okay, so if you just go ahead and explore this completely till the end, you will be able to get all the URLs, everything over here, right? And finally, after getting the structured output, the main agent is able to combine them and finally generate this specific output. Okay. And that is how your output is basically coming up. So I hope you are able to understand about subagents. The most important thing is that if you're using Claude Code also, there also you have subagents, you have agent views and all. And the same thing we are trying to build it with the help of Langchain XDK over here. And we are using this deep agents in order to create that, right? So yes, this was it about subagents, and I hope you are able to understand it. So finally, guys, now it's time that we will go ahead and use all the amazing topics till now we have discussed in this entire deep agents module, right? We have discussed about so many topics. You'll be able to see that how to develop a basic deep agent, then context engineering, backend, sub agents, how to develop skills. Along with that, the importance of agent.md file. And we could see that by just customizing all the specific parameters, you are able to do something very amazing, right? Now, what I will do is that I will specifically use Claude Code. So let me just go ahead and open Claude Code. And with the help of Claude Code, I will say that, hey, create me a Streamlit app. So I'll say, create me a Streamlit app, which will act like a conversational chatbot, okay, which uses all the features, all the features, all the features discussed in the deep agent demo folder, right? So we have discussed about so many things, right? From basic agents, deep agents, to context engineering, to backends, to sub agents, so many different topics for them, right? I want to include all the features. I want you to include all the features. You to include all the features explained in the notebooks uh, related to deep agents. Now I am just going to go ahead and do this, and automatically now my code will get generated. I will go ahead and create a Streamlit app, and my main aim is basically to run that app and show you that after implementing all these things, right, how an amazing end-to-end projects look like, right? Obviously, I'm using Claude Code. This is the most efficient way to write a code right now, and everybody should start using AI coding agents. Okay, so it has been exploring all the notebooks now. Okay, searching for one pattern, reading 5 files, all the specific files. It will go ahead and read all these things, right? From skills to probably memory, each and everything, context engineering, everything it will try to use, and it will probably go ahead and create a Streamlit app. So till this is getting executed, I will keep on giving the approvals, and after the file is basically created, I will show you that. Okay. So finally, guys, after some time, the entire code has been specifically written, and now if we run this Streamlit app, okay, in order to run the Streamlit app, you need to use the command streamlit run streamlit_app.py. So this is the entire code that has been specifically written, and Claude Code has already done this for me. I just gave the context with respect to all this IPYNB file, and automatically all the specific code is there. I think if you read it, you should be able to understand it. But if I run this, you should be able to see this is how it looks like. Here you can select any different kind of models that you want. Let's say I will go ahead and use OpenAI GPT 5.5. Let's say whatever conversation that we are doing, we can save it in state backend, file system backend, store backend, wherever you want. It is loading on. As soon as this deep agent chatbot is basically loading, you'll be able to see that we are loading the agents.md file. The skills is also getting loaded over here. And based on the question, specific skills will get required. So let me go ahead and do. I will just ask something like research about LLM gateways and provide me a detailed summary. So if I go ahead and ask a question, then you should be able to see that now it will go ahead and do the planning, research, and delegating. Even it'll, if there is a specific sub agents, because I've also created a sub agents, I want to also use that, right? So it will go ahead and delegate those sub agents the work, and then you should be able to get the output. About this deep agent is that it'll be able to do the planning. It has virtual file system access, context engineering, skills, sub agents, swappable backends, thread memory via checkpointer, many more things, right? Yes, since and the system prompt is also here. You are an expert AI assistant and researcher. You conduct through research using internet search tools when it is needed, plan multi-step work with right to-dos, offload bulky query matches, and delegate deep dive researches to your sub agents. Okay, only the first result, it will take some amount of time, but once this is done, you'll be able to see the amazing response that you'll be getting. So here you can see, guys, finally it has given us the entire output. Okay. And you can see that an amazing output it has basically given. It has done all the planning, such an important research it has basically done along with, and see what all things it has done. So here you have planning right to do's. It is gathering current information on LLM gateways, synthesizing, finding a detailed. Then there are some to do's that needs to be done. Then it has done a web search. And obviously for doing this, it may have given, or it may have delegated the task to the sub agents over here. And then it probably did this again, web search, again internet search, planning, writings, right? It has also taken the report writer skill.md file, which we have specifically created. Then it also had instruction.md file, so it is also been loading that. And finally your detailed output is over here. Okay, let's do one thing. Let's uncheck all these things so that we should be able to work quickly. Okay, so let's say I will go ahead and write how to initialize an EC2 instance. So this is how it is specifically working, right? In Claude code also, if you try to use Claude.ai, I know right now you'll get taking some amount of time to get the output. But I think based on, and this is running in my local yet, right? And here you could see that sources are also here. So what kind of research it has basically done in the internet, right? So here you can see I have given the skills access, how to initialize an EC2 instance. It should definitely use the skills of AWS. That skill is already created. And here also you could see the virtual files in state, right? And this report has got been created, the entire report, right? So beautiful, right? And you can basically see in Claude.ai also it will take so much of time, right, to do the proper deep research. I'm not just talking about a simple questions and all, and it is internally using so many different skills and all, right? And here you could see this also output we have actually got it, right? I asked about EC2 instance, so file system. It has picked up that AWS skill.md. Isn't this amazing, right? And this is my read file. It is reading this entire thing. And instruction MD file, it is reading it, right? And then it is basically writing down the result. And the result is amazing because it is using another skill, right? Report writer. So I hope you were able to understand this amazing crash course on building about deep agents. This was it from my side. Please make sure that you keep on doing different kind of tasks. Obviously, all the information, all resources will be provided to you, right? So yes, this was it from my side. I'll see you in the next video. Thank you. Have a great day. Bye-bye.